Organized by Department of Mechanical Engineering at Amity School of Engineering and Technology, Amity University, Uttar Pradesh, Noida. This is a three-day conference starting from 3rd of August till 5th of August.
Amity University is India's leading research and innovation-driven private university. With the blessings of our Honorable Founder President Sir, Dr. Ashok K. Chauhan, Amity has been able to create an atmosphere of imparting world-class education and also nurture budding talent and potential leaders of the world. At Amity, we are passionate about grooming leaders who are not only thorough professionals, but also good human beings with values and sanskars.
Today's event will begin with 2 plenary talks, then 5 parallel keynotes will begin, followed by 5 technical sessions. Following that, we have organized an industry-academia interaction in the form of a panel discussion, followed by the valedictory function in the E-2 auditorium itself. We will now begin with the first plenary talk. I'd like to introduce our speaker for the first plenary talk, Professor Dr. Ankur Jain, Associate Professor at Department of Mechanical Engineering and Aerospace Engineering, University of Texas, Arlington. We would like to present a sapling and welcome him for his presence. So I request the audience to please give a huge round of applause as we welcome our guest. I also request our Head of Department, Dr. Basant Singh Sekawar, sir, to kindly accompany our guests. Give a huge round of applause as we present a token of our gratitude. And thank you, sir, for his presence today, for making it to our conference. I also request our guests who are off the dais to kindly come for the felicitation. Give a huge round of applause as we present our guests on the dais. We present a token of gratitude to all our guests for their presence with us today on this 3rd day of the conference.
Professor Dr. Ankur Jain is an associate professor in the Mechanical and Aerospace Engineering Department at the University of Texas, Arlington. His research interests include energy conversion in lithium-ion batteries, microscale thermal transport, additive manufacturing electrochemistry, and applied mathematics. He has published several journal papers and given 60 invited talks, seminars, and tutorials. He received the UT Arlington President's Award for Excellence in Teaching in the year 2022, UT Arlington College of Engineering Outstanding Early Career Award in 2017, NSF Career Award in 2016, and the ASME EPP Division Young Engineer of the Year Award in 2013. He received his PhD in the year 2007 and MS in the year 2003 in Mechanical Engineering from the Stanford University, where he received the Stanford Graduate Fellowship, and BTech in Mechanical Engineering from the Indian Institute of Technology, Delhi, with the top honors. I welcome you, sir, and invite you to please deliver your talk.
The topic of his plenary talk is heat transfer in lithium-ion batteries and interface of imaginary eigenvalues and thermal runaways. With that, I welcome you, sir, and over to you now.
So while we figure that out, let me start speaking. It gives me great pleasure to be here and talk to all of you, especially the young students in the audience. I remember I was one such student not too long ago and not too far away from here. I grew up in New Delhi. I did my undergrad here in IIT Delhi. And I was a student such as any one of you, trying to figure out what to do with my life. And I'm glad when I look back at the stuff that I did. And I'm honored, thank you very much, for the invitation to come and speak to you all about the research that I do. I think we are ready, so I can get started. मैं ये use करूँ? Thank you. So my name is Ankur Jain, and I am an associate professor of mechanical engineering at the University of Texas at Arlington. Am I audible in the back? Can you all hear me? Good, good, wonderful. So today I will talk about heat transfer in lithium-ion batteries. This is some work that my students and I have been doing for the past 7 or 8 years, and we've done some very interesting research, both experimental and theoretical, on heat transfer aspects of lithium-ion batteries. Of course, batteries are a very interesting topic of research. As you all may be aware, there is a lot of work going on in India about electric vehicles, electric scooters, and things of that nature. And one very common problem in those transportation systems is that they catch fire. And clearly that is not something any one of us wants. And so trying to understand how heat transfer occurs in lithium-ion cells and in large battery packs is a very important technological question. And so today I'll talk a little bit about that. I'm happy to take questions at any time, so if you have any questions, please feel free to interrupt me, and I'll be happy to take your questions. So before I start, I want to acknowledge my students, both current students as well as alumni, collaborators and funding sources for all the work that we have done. I would not be standing here without the support of all my collaborators, funding, and my students. Cool. So let's start with the basics. What is a lithium-ion cell? A lithium-ion cell is a device that can store energy. So when you have excess energy, you can pump that energy into the cell where it will be electrochemically stored until you need it back. At that time, the lithium-ion cell will provide energy back to you, right? How many of you have a cell phone? Right? So you all have a lithium-ion cell in your pockets, and that is what makes the world possible. That is what makes it possible for us to check email on the go. That is what makes it possible for electric cars to go wherever you want them to go, and so on and so forth. It turns out that a lithium-ion cell is a multi-physics, multi-scale system. There is a lot of very interesting physics that goes on in a lithium-ion cell that makes it a very interesting system for us as scientists and engineers to study. So for example, there is electrical transport, electrochemical transport, as well as thermal transport that occurs in parallel with each other and that influences each other. So you can see from a scientific perspective that this is a very rich system for us to study that involves a lot of very interesting open questions that need to be answered. In particular, my interest in lithium-ion cells is related to heat transfer. And so there are a lot of very important heat transfer questions that occur in a lithium-ion cell. It is very well known that if a lithium-ion cell exceeds a certain temperature, about 70 or 80 degrees Celsius, then it can get overheated very rapidly, and it can enter what is known as thermal runaway, which causes the cell to explode in a very dramatic manner. If you go to YouTube and just look for lithium-ion battery fire or something like that, you will come up with some very dramatic videos of how cars and airplanes and cell phones and e-scooters and things like that have caught fire because of overheating in a lithium-ion cell. So from a scientific point of view, it is very important for us to understand why is it that a lithium-ion cell gets so hot, and what can we do to design better lithium-ion cells that will allow us to go faster and longer and keep our cell phones charged for longer periods of time, and so on and so forth. So today I will talk about three key lab, and through this I will try to cover experimental work, simulations, as well as some mathematical theoretical work that my students have carried out. So I will start by first talking about some measurements of thermal transport in lithium-ion cells, which is the first part of my talk. In the second part of my talk, I'll talk about some simulations that we have developed for understanding the propagation of thermal runaway. So the question there is that if I have a large pack of cells and if one cell catches fire, then what is the likelihood that that cell will cause its neighbors to catch fire, which will cause their neighbors to catch fire, and so on and so forth. And then in the third part of my talk, I'll talk about some multi-layer diffusion reaction analysis that we have carried out for understanding thermal runaway in a lithium-ion cell from a purely theoretical point of view. So let's start with talking about thermal measurements in lithium-ion materials. So the basic idea here is that if you cut open a lithium-ion cell, it turns out that a lithium-ion cell is a highly heterogeneous system. In other words, there are multiple materials and multiple interfaces that come together in order to form the lithium-ion cell. And therefore, in order to understand the overall behavior of the lithium-ion cell, it is important for us to understand the thermal properties of individual materials and of individual interfaces. And so towards that, we have carried out in our lab measurements of the thermal properties of a lithium-ion cell and that of its materials. So we started in 2014 by taking a single lithium-ion cell that looks sort of like this, right? And in order to measure its thermal properties, we wrapped a flexible heater around it, and we put a thermocouple on the outer surface. We put insulation tape around it, and then finally we put it inside a vacuum chamber, and we started heating up this cell. So from a theoretical point of view, it turns out that if you solve this theoretical problem, the temperature rise in this lithium-ion cell is predicted to be a function of time in this manner. There are three terms in this equation. The third term will die away very quickly. And so the prediction is that after some time, the temperature of the cell will become a straight line function of time. And if you can figure out the slope and the intercept of this straight line, then that involves the heat capacity and the thermal conductivity of the cell. So in other words, if you can figure out this straight line as a function of time, then the slope and the intercept of that straight line should give you information about the thermal properties of the cell. So we carried out measurements, and it turns out that our measurements were very much in agreement with the theoretical prediction. You can see that at small times there is a curvature in the measurement, but a little while later it becomes a straight line. You can see there is good agreement between the measurements and the model, and from there we are able to extract the thermal properties of the cell. The most interesting part of this result, I think, is the fact that the radial thermal conductivity and the axial thermal conductivity are very different. If I take a slab of copper, for example, the thermal conductivity of that slab is expected to be the same in all three directions. But a lithium-ion cell, because of the way it is made, sort of like a toilet paper roll, because of that, the thermal conductivity in the radial direction and in the axial direction turns out to be very different. You see, the way a toilet paper is rolled, heat can flow in the axial direction along the roll. Whereas if the heat has to flow in the radial direction, it has to jump from one material to the other. There are multiple interfaces, and at each interface, there is going to be additional thermal resistance, because of which it will become more and more difficult for the heat to flow in the radial direction. And so this, I believe, was the first ever measurement in which we showed this through data, and we were able to obtain about 100x difference between the axial and the radial thermal conductivity. Yes. So it turns out that in this case, there are multiple materials and interfaces involved in the cell, and therefore the values that I'm providing here are the overall effective values. which involve contributions from each material and each interface within the material.
So you say that overall thermal conductivity.
Exactly.
Got
This is the overall thermal
overall.
conductivity.
Thank you. Thank you.
Yeah.
Okay.
Any other questions or comments?
No, it's okay. Go ahead because.
Yes.
Slide number 10, can you go slide number 10?
Yes.
Okay. So in this slide, I can see that the heat transfer equation that you wrote here, 1 upon R del R of del theta by del R equal to rho Cp by Kr and this. This is only for the Kr, radial direction.
Correct.
Where is the axial direction equation?
Good question. I don't show that, but there is a separate measurement in which we insulated the radial direction and we applied heating on the axial direction.
Okay, and in this equation, there should be the heat source Qt in the axial direction. Then we can solve in this way.
Right, there is
Theta
no
R
heat
equal
source.
to 2 Qt. Where is the Qt in this equation?
There is no heat source here because the cell itself is not generating any heat. I am providing heating to the cell from the outside.
So
Because of
that
which,
outside should be given from the boundary to the.
correct, and here is the boundary condition.
Okay, okay,
Got it?
that's it. Okay, thank you very much.
Yes, absolutely. So this motivated further work. We wanted to understand why the radial thermal conductivity of the cell is so poor. If you take a look at all the individual materials of the cell, such as anode, which is made up of graphite, or separator, which is made up of porous polymers, each of those individual materials have reasonably high thermal conductivity. And yet, when you put them together, the thermal conductivity of the overall system turns out to be very small. Right? It's like 4 kids who are very good at building a tower. But if you put them together, then they fight with each other and the tower never gets built. Right? So it turns out that this data gives us a very strong hint that interfaces between these materials may be responsible for the poor thermal conductivity of the cell. And so then my student carried out careful measurements of the thermal properties of individual materials and the overall thermal properties, and he subtracted it out to determine the thermal contact resistance inside the lithium-ion cell. And here is a summary of his measurements. This, what I am listing here, are the thermal contact, the thermal resistances of individual materials as well as the interface inside the cell. You can see that the materials themselves do not contribute much to the overall resistance, but it is the interface that completely dominates the game of thermal conduction inside the cell. In fact, the interface contributes about 88% of the total thermal resistance of the cell. So if you are interested in improving the thermal properties of the cell, if you are interested in removing heat from the cell as quickly as possible, there is no point in improving the thermal properties of the cathode or the separator. What you have to focus on is the separator-cathode interface. And then as a follow-up to this, my student also carried out some measurements in which he carried out a surface functionalization at that interface. Crudely speaking, he applied glue between the two surfaces, which allowed the two surfaces to come together much more intimately. And that, he showed, reduced the contact resistance dramatically. About a 4x reduction from 840 microkelvin meter square per watt to only 180 microkelvin meter square per watt. And when we do that, we predict that the overall thermal resistance of the cell comes down dramatically. This cell is expected to remove heat much better than the baseline cell, which is the state of the art today. We have some data to show that this does not deteriorate the electrochemical performance of the cell while giving us the required improvement in its thermal properties. More recently, we have done molecular dynamic simulations in our lab which confirm some of this experimental data. So through molecular dynamic simulations, we have shown about 250% improvement in the contact resistance, which is very similar to the kind of experimental improvement that I just showed a few slides ago. So I'll move on to the second part of my talk, which is on cell-to-cell thermal runaway propagation in a battery pack. The idea here is very simple. If I have a pack of cells, in an electric car, there are typically 5,000 to 10,000 individual cells in a large battery pack, right? And there I am worried about propagation of lithium-ion cell. If one cell catches fire, and if the damage is limited only to that cell, then that's not such a bad thing to happen. Because then I'm only losing one cell out of 10,000, and my car will still run, right? But if that cell gets so hot that its neighbors catch fire, and because of those neighbors, their neighbors catch fire, and so on, then I'm in trouble. I cannot overcome the temptation of comparing this with COVID-19, right? This is exactly what happens in COVID-19 as well. One person has COVID-19, because of which his or her neighbors catch COVID-19, and then their neighbors catch COVID-19, and so on and so forth. If it was possible for me to limit that to only one person, that would not be that bad a situation compared to if the entire room gets COVID, right? So the analogy here is that I would like to figure out what can I do in order to prevent the propagation of thermal runaway. And you might guess, very similar to COVID, that one strategy is social distancing. If I can keep my cells far enough from each other, then the heating in one cell will not reach the neighboring cells, and I would be saved. But in an electric car, I only have very limited space. I cannot design my battery pack to look bigger than the car itself, for example, right? So there is an engineering trade-off that we need to understand and optimize there. I want to keep my cells close enough so that my energy storage is compact, but I don't want my cells to be so close that propagation of thermal runaway occurs. So towards that, one of my students has carried out some very complicated non-linear simulations in which he has accounted for a number of non-linear highly coupled phenomena. I'll show you one quick example here. What I will show here, hopefully the video will work, is a 3x3 pack of cells. One cell will catch fire, and we are going to plot the temperature map in the entire battery pack, and we'll try to see what happens to the neighboring cells. So it's this cell that's already catching fire, and you can see that it begins to heat up, and boom, the entire battery pack catches fire. You can see how quickly thermal runaway spread. I started with only one cell that had caught fire, but because this process is so highly non-linear, because of Arrhenius heat generation and so on, that cell will spread to the neighbors, and it will spread to the neighbors, and within no time the entire pack would have caught fire. Let's look at it once more. Right now things are okay, but at some point in time the whole thing will boom, and everything is gone at this point. The time scale for this simulation is about 200 seconds, but that spread occurs within 1 second. Within 1 second. It's a highly non-linear process, as you can see here. So through this simulation tool, we carried out investigation of the effect of cell-to-cell gap. So you can see here that if my cell-to-cell gap is 4 millimeters, then thermal runaway does not spread. It is only limited to the trigger cell. Everybody else is reasonably cool. But if my cell-to-cell gap is 1 mm, I go from 4 mm to only 1 mm, and at that point, everybody in the battery pack has caught fire. So you can see that there is a threshold cell-to-cell gap. We believe it is about 2.5 mm, below which my battery pack is at very high risk of catching fire. So this is a very practical guideline based on some very rigorous simulations that I can hand over to engineers and tell them, look, this is the minimum cell-to-cell gap that you must have in order to keep your cells safe. We've also looked at the effect of the trigger cell location. The trigger cell could be located either in the corner or in the center or pretty much anywhere. And we've seen how the location of the trigger cell also makes a big difference in whether thermal runaway propagation occurs or not. Basically, the idea is that if my trigger cell is at the corner, then it is located very close to the cooling boundaries. But at the same time, it also has fewer neighbors to spread the heat to. So the same amount of heat is being spread only to 3 neighbors here, as opposed to maybe about 8 neighbors here. So there is a trade-off there. Sometimes it is better for the trigger cell to be at the center, and sometimes it is better for the trigger cell to be at the corner. We don't know which one of these will win in real life, but at least through these simulations, we have a tool that allows us to rapidly evaluate potential design choices. Exactly. Yes, and just to add to that, in India, we are typically not concerned about very cold climate, but in other countries, it gets so cold that you have to heat up the lithium-ion battery pack before you can start your car, because the lithium-ion cells also do not work very well at very low temperatures. So I'm talking here entirely in the context of cooling a cell down, but there is also important work to be done in heating up the cell when the climate is very cold. Finally, we've also done some simulations on understanding the optimum thermal conductivity of the material around the cell. So if I go back a few slides, all these cells are contained in an interstitial material. It could be air, or it could be some other material like wax or metal and so on and so forth. And it turns out that if the interstitial material thermal conductivity is too low, or if it is too high, then either of these scenarios are very undesirable. Because when the thermal conductivity of the interstitial material is very low, then it's like putting a blanket around your cell. And therefore, even a very small amount of heating in the cell will cause that cell to overheat. On the other hand, if the interstitial material thermal conductivity is very high, then what that means is that heating from one cell will reach the neighboring cells very easily. And there would be a problem, because the spreading, the propagation of thermal runaway will occur very rapidly. And therefore, we've concluded that there is an optimum not too high and not too low thermal conductivity, which is best for optimizing between these two extremes. More recently, we've also enhanced these simulations to account for secondary effects, such as the venting of hot gases. When a cell catches fire, oftentimes it ruptures, and through that little hole come out extremely hot gases, typically at temperatures like 1500 Kelvin, traveling at speeds like 200 to 300 meters per second. So these very hot, very high-speed gases will also spread thermal runaway from one cell to the other, and that's also something that we have done. And actually, very recently, we are working on a revision of that manuscript. We've also accounted for combustion of these hot venting gases. These gases that come out of the lithium-ion cell are highly flammable, and they can and they do catch fire once they are outside the cell. And of course, whenever something catches fire, there's a lot of heat generated, and we have been able to account for that in our simulations as well. That's a good question. So it depends on the nature of the lithium-ion cell. There are different chemistries, right? And different chemistries produce different types of gases, right? And therefore it is a chemistry-dependent contribution. So in the interest of time, I will move on to the third part of my talk, in which I will talk about some theoretical mathematical work for predicting thermal runaway through multilayer diffusion reaction analysis. In some sense, this is my favorite part of the talk because I like mathematics, and some of the work that we've done, I feel very happy and passionate about. So what is thermal runaway? Thermal runaway is a scenario in which there is positive feedback between temperature rise and heat generation. So what's happening is that I have a lithium-ion cell that contains some chemicals which generate heat according to a decomposition reaction, right? And as you all know, the higher the temperature, the greater is the rate of that reaction, right? That is why food spoils faster if you keep it outside, whereas if you keep it in the fridge, then it will last longer, right? The decomposition reactions inside the food will occur faster at a higher temperature. So what happens in a lithium-ion cell is that if it gets very hot, then those decomposition reactions will happen faster. They will generate more heat, right? But what happens when you generate more heat? The temperature of the body rises, right? But when the temperature of the body rises, it then begins to generate even more heat. And you can see that this is a positive feedback between temperature rise and heat generation. And very soon, if you do not control this, then the temperature of the cell will keep rising until such time that the entire cell catches fire, and that's the end of the story, right? So we wanted to understand this from a theoretical point of view, and try to come up with conditions in which such positive feedback loop will not cause complete destruction of the cell. So for that, we write a governing energy equation for this system, in which my heat generation is a function of temperature. And we carry out a first order Taylor series expansion of Q of T, based on which we derive an expression for the temperature rise in the cell. Okay? What is interesting about this is that there are two terms inside the exponential. And therefore, whether the temperature of the cell rises exponentially at large time or decays to 0 depends on the sign of this term in here. If this term is positive, your cell is doomed. If this term is negative, then it will be an exponentially decaying term, and at large times your temperature rise will be 0. So what I'm showing here is that in order for the cell temperature to stay bounded, this term inside the bracket must be less than 0, based on which we derive a very simple expression, beta r square over kr mu1 square, the value of which should be less than 1 in order for thermal runaway to not occur. This turns out to be a non-dimensional number, which we decided to call the thermal runaway number, the value of which should be less than 1 in order for thermal runaway to not occur. So those of you who have already taken heat transfer or fluid mechanics know very well the rich history of non-dimensional numbers in heat transfer and fluid mechanics, right? Reynolds number, Nusselt number, BO number. I'm sure you all can count 5 other non-dimensional numbers. Here is one more non-dimensional number in that list. This is very specific. It tells whether thermal runaway in a cylindrical heat generating system will occur or not. From a more practical point of view, I can give this number to a designer and say, look, I would like to make sure that you choose parameters in such a way that the overall number defined in this manner is less than 1. If it is less than 1, that you have reasonable confidence that thermal runaway will not occur. And you can see that this thermal runaway number has contributions from chemical kinetics, thermal conduction, convection, and geometry, all rolled into one single number. Right? So this is an integrated analysis of the problem. Yes? Exactly. Exactly. The problem is that, if I take a lithium ion cell that looks like this, most of the cooling occurs on the radial surface because the top and bottom surfaces are already occupied by electrical connections. So I cannot blow air over the top and the bottom surface because the surface area is anyway very small, right? Which is why I am limited to removing heat from the radial surface, even though the radial thermal conductivity is very poor. Absolutely. The higher the radial thermal conductivity, the better it is. Yes. Small cells, not very large. And finally, mu, which is the first root of the eigen equation, should be as large as possible. Thank you. So we have some experimental validation of this. We have shown that some experimental data in our lab agrees with this idea of the thermal runaway number. And based on this, we are able to carry out design space optimization. What area in the design space is safe and what area is not safe. So for example, here we are showing that the bluer you are, the safer you are, and the redder you are, the less safe you are. And this black line basically separates the safe region and the unsafe region. Now, more recently, we have generalized this to a multi-layer analysis. What I had shown a few slides ago was a single layer analysis. It assumed as an approximation that the cell is a homogeneous body, whereas in reality, the cell has multiple layers of different materials. So we have very recently extended, generalized the analysis to be able to account for the multiple layers and the properties of those individual layers. So what I've done here is to consider a multi-layer problem in which there is diffusion and reaction occurring simultaneously. There are convective boundary conditions at the top and bottom. And I am interested in figuring out whether the temperature rises exponentially as a function of time, or whether it will decay at large times. So in order to solve this problem, we first carried out non-dimensionalization. You can see all the usual culprits here. This is the Fourier number, this is the Dam-Kohler number, and these are the BO numbers. This is the non-dimensional set of equations that I need to solve. And we have derived a solution for this problem using separation of variables and the principle of quasi-orthogonality of eigenfunctions in a multilayer body. The most interesting aspect of this problem, at least for me, is the fact that some eigenvalues of this problem may become imaginary at large times. So you see the solution for this problem is written here, where lambdas are the eigenvalues of this problem, and we have shown that under certain conditions, some of these eigenvalues may become imaginary. And you can see that if lambda becomes imaginary, then lambda square is negative, and therefore the exponential term becomes positive overall, and therefore the temperature will rise exponentially over time. What that means is that the mathematical phenomena of the eigenvalue becoming imaginary corresponds to the very practical observable phenomena of thermal runaway in the lithium-ion cells. In other words, in order to predict whether thermal runaway will occur or not, from a theoretical point of view, all I need to do is to figure out conditions in which my eigenvalues may become imaginary. And we have done that. We have derived a condition under which eigenvalues may become imaginary. This may be of interest to those of you who are familiar with the theory of thermal conduction. In most cases, eigenvalues in thermal conduction problems are real, right? You typically plot the eigenvalues and you look at where the eigen equation crosses the x-axis, and those are the eigenvalues of the problem. And typically this is done only along the real axis. But in this particular problem, it turns out, under certain conditions, that if I plot the same graph in the imaginary, along the imaginary axis, in other words, where lambda n square is negative, then the eigen equation or the eigen curve may cross the x-axis under certain conditions, and that is where we get imaginary eigenvalues. And through our analysis, I will not go into the mathematical details, we have been able to derive a condition under which such imaginary eigenvalues may occur. And this allows us to design this system from a theoretical point of view. I can predict regions in which the system will diverge and in which the system will converge, and the boundary between those two. I can predict how the strength of my imaginary eigenvalue varies as a function of how strong the heating is and how strong the boundary cooling is. And so these curves and other such curves can be used for practical design of lithium-ion systems in order to prevent the occurrence of thermal runaway. As an example, here are two different problems. In the first case, I have two lithium-ion cells, only one of which is generating a very mild amount of heat. And you can see that starting from some initial temperature, the temperature field in this body keeps going down until the temperature decays away and everything is fine, right? But on the other hand, if I consider another scenario in which one of the cells begins to generate a lot more heat, you can now see that as time passes, the temperature of my body begins to rise. And it begins to rise faster and faster and faster. And I did not plot the tau equals 3.0 plot here, because that plot is at 1000 or something like that. It's an exponentially rising curve. There is no way you can fight with an exponentially rising curve. It is destined to explode and kill your entire system, right? So you can see that the amount of heating inside the cell governs whether this system is stable or is not stable. And these and other scenarios we have shown can be modeled within the framework of imaginary eigenvalues. We've also done some mathematical analysis of the number of imaginary eigenvalues. I will skip this in the interest of time, but just to show that we've been able to derive a mathematical expression for the number of imaginary eigenvalues that exist in this problem. And here is a map of how many imaginary eigenvalues to expect. starting from zero, rising as you become more and more aggressive. So I'll begin to conclude here. Just a few more comments. We have carried out analysis of other multi-layer, multi-physics problems, including some very interesting problems in drug delivery. So if a person gets a stent installed is not the right word, delivered or something like that, placed by a surgeon in their artery, then this stent oozes some medicine into the artery of the person. And this is a very interesting convection diffusion reaction problem in a cylindrical body, in a multi-layer cylindrical body. And in collaboration with some folks, we've determined some models for this problem. Similarly, drug delivery from spherical capsule. Any one of you takes a medicine, typically those capsules are multi-layer in nature, and it is of interest to predict how the drug will diffuse out of the multi-layer capsule, and we've developed some models for that as well. And so to summarize, today I talked about heat transfer in lithium-ion materials, cells, and battery packs, which I believe play a very important role in determining the safety and performance of lithium-ion battery packs. This is very relevant all around the world, and particularly in India, where there is a lot of emphasis on electric vehicles, such as electric cars and electric scooters and so on. We have to ensure the safety of such systems if you want everybody to drive around in an electric vehicle. And one more thing, especially to the students, I will say that an integration of rigorous theory and experiments is important. It's not enough to be a good experimentalist. It's not enough to be a good theoretician. What really is needed is for both of these to come together in harmony with each other for a good, thorough understanding of the system. So with that, I will conclude here. On behalf of my students, once again, thank you very much for the invitation. It was a pleasure giving this talk, and I'm happy to take any questions.
Thank you very much, Dr. Ankur. It was nice talk. I hope the student take the good advantage of this knowledge, and definitely whatever you putting in a very, very informative and important for all students, because you know that lithium-ion batteries cooling is a biggest problems like this. So I am just want to some question from student side. Yes. No, I think whole day he is with you. Huh? So you will connect with him. Yes, please. Mic take that.
Good morning, sir. So for the whole talk, we've been focusing on the assumption that one of the cells will undergo thermal runaway, right? So shouldn't we increase the axial conductivity and put the cells closer so they share the heat between them, and none of the cells can achieve thermal runaway in the first place?
A good question. The problem is that the cell that undergoes thermal runaway generates so much heat that if you share it with its neighbors, then there is a risk that the neighbors will also overheat enough that they begin to generate their own heat. Right? It's again going back to COVID, it's like a virus. Right? If I give just a little bit of virus to you, right, the virus will begin to multiply inside you, and then you will become a carrier and you will give the virus to the neighbors. Right? That is why I don't want to come too close to you. Do you see what I'm saying?
Yes, sir. And so second question that I have is, does power density of a cell, a lithium-ion cell, has direct connection to the thermal runaway tendencies of the cell?
Yes, absolutely. The more power there is inside the cell, the more heat that it is likely to generate. Okay. Right? And therefore, the more at risk it is of undergoing thermal runaway. And there is unfortunately a trade-off here. Electrical engineers want to pack as much energy in the cell as possible so that the battery pack is lighter and has very high energy storage capabilities, right? So that your electric car can go very, very far, right? But as mechanical engineers, we have to caution them that, look, if you are going to increase the energy storage density too much, then you enter a risk of thermal runaway. So there needs to be a harmony between these two conflicting requirements.
Okay. Which semester are you?
Third semester.
Good. So good question, actually.
Yes.
Next, you? Yes, can you share this?
Good morning, sir. Very nice and impressive research work. So I just wanted to get a clarification on the application perspective. So this research is specifically limited to the lithium batteries, or can it be used for currently running nickel cadmium or nickel polymer batteries also?
Well, typically nickel cadmium or nickel type batteries do not have such a grave problem as lithium ion cells. They also generate heat, but they do not generate as much heat as lithium ion cells do. So primarily the challenge is with lithium ion cells and possibly with other future chemistries. So people are already, material scientists are already beginning to look at lithium air, sodium sulfur, all kinds of different chemistries of cells. And as mechanical engineers, I think it's important for us to get a seat on the table to be able to solve such heat transfer problems early on.
Right, sir. Thank you.
Yep.
Any other questions? Please, student side, because you know that in final year some students have a course, battery management. So here there is a course, battery management. Yeah.
Ankur, somewhere I'm not happy with you. You go to that slide.
Which one?
That where you have trying to find that eigenvalues kind of things.
Please stop me wherever.
No. Oh,
This
go
one?
for the method. I'm talking about the mathematical analysis. Yep.
Mathematical analysis.
Right.
This one?
You go to the governing equation.
Sure. There you go.
You are taking this axial conduction here, all right?
So this way, the problem.
No. Let me finish my question.
Sure.
You are considering the axial conduction here, right?
No.
What? This is the radial direction.
No.
Then
This is-
what?
This is a Cartesian problem. We have posed this problem only in the x direction.
No, axial or radial? You tell me, please.
No, only it's a Cartesian problem.
Cartesian problem means?
In XYZ, in XYZ, I am considering a one-dimensional body.
That means you have combined the variable.
Sorry, say that again.
You have combined the variable.
No, so this analysis is a completely theoretical analysis. That
Please,
has nothing
please
to
tell me. I am a dumb fellow. You tell me that what is the existence of this coordinate? Physical existence of this coordinate.
So in any body which is one-dimensional in nature, these equations.
In your battery, whether it is radial direction or axial direction.
So batteries come in all kinds of shapes. Batteries are cylindrical.
You are doing the analysis for a particular cell, no? Particular cell.
No, not necessarily. This is a completely theoretical analysis.
वो तो है, मैं देख रहा है comparative. But I am talking about that existence of this coordinate, physical existence of this coordinate. That's what I am trying to find out.
This coordinate will physically exist in any scenario in which the system is one-dimensional in nature.
In-dimensional on nature.
In addition to
I am
the
talking about-
cylindrical, may I complete, please?
Yes.
In addition to the cylindrical cells that I have shown, there are also pouch cells that look like a box. These cells have a very high aspect ratio, because of which it is reasonable to model those cells as one-dimensional in nature, which is sort of what is being done here.
I understand. What I am trying to say, I am not fully, maybe that this axial direction or radial direction, you have the battery, no? Radial direction and axial direction is there.
Yes.
This coordinate system, you are not trying to convince me still whether it is kind of this kind of things. And go to that. Before that last slide, you go that.
Yes.
Last slide. No. Oh, previous.
Slide number.
उसका previous. Previous. जहाँ first governing equation लेते हैं.
The first governing equation here is shown here.
This is. There is one time-dependent equation was there.
Yes, this is a time-dependent equation. Here is the transient.
ना उसका पहले जो heat generation term था, जो equation दिखाया था आपने.
Slide number बता दीजिए मेरे को.
No, I'm talking about which.
Slide number 11. No, but that was a different
That
experiment.
is different, I think.
That was a
Sir,
different problem.
Actually, we will discuss these things during the tea time.
What I'm trying to say, where you have ignored one term.
Is
Yes,
this-
yes.
Yes. So this is-
I'm talking about this one. Now, one term that you have ignored that axial conduction, right?
Sir, good morning. Sir.
Right,
Please.
this is a very different problem. This problem was derived in order to match experimental data only for measuring the thermal conductivity of the cell.
I understand. Yeah, I understand.
The
You are
way-
trying to find out the thermal conductivity, right?
Correct.
Okay. And you are not considering the axial direction.
That is because I have insulation on the top and bottom, and I am heating up the cell from the radial surface,
Right.
and therefore the flow of heat is expected to occur only in the radial direction,
ठीक है.
which is why it is reasonable for me to ignore or treat axial thermal conduction as negligible.
Sir,
Achha,
sir, I
ठीक
think
है.
both cases are different.
Now, both cases, he is simply trying to find out that thermal conductivity here
Correct.
only.
So
And one more thing, that you have ignored the axial conduction.
Correct.
But axial conduction will be there when you are doing the. But is it necessary to consider time frame to do the that eigenvalues?
Yes, eigenvalues can only exist in a transient problem.
No, you can have that in spatial coordinate also eigenvalues.
Right, but
So
the
it is not, no, eigenvalues of a system does not depend whether it is the time dependent or
Sure,
axial
but,
dependent.
but
Understand
the way we wanted to pose this problem
Yes,
was,
yeah.
the question that we wanted to answer was, what happens to the temperature at large time?
I understand. You ignore the axial direction term, you have taken the time direction term. So that's why you are taking the eigenvalues, no?
Correct,
And-
yes.
Yeah.
Sir, I think
Thank you.
very
Thank you.
much. You think more detail about during the high tea. Thank you. Okay,
I'm
because
done.
Next speak. Okay. Thank you. Yes, you want to some? Yes, Dida, sir. So I think he's. Yes, please.
Dr. Atul Jain, beautiful presentation. Come in the interstitial materials slide.
This one?
So in interstitial materials,
Interfacial kind of slide.
Oh, the simulations?
interstitial materials.
Right, let me go to the simulations. Here.
So in these materials, a metal lattice having a hole. Okay? So in that perspective, atomic structure you have taken care in your study.
No, sorry, the word interstitial here does not refer to the crystal structure. The word interstitial here simply refers to the material around the cell. That is all. I'm not doing...
Only. So interstitial materials you are not considering.
No, not at all. This is not a crystal level simulation. All I'm saying is that I have multiple cells. What is the material around the cell?
Okay.
System
Is there
level
just air
simulation.
between the cells?
So because the lithium ion batteries, now due to this sort of a heat transfer problem, we are switching over the niobium.
Yes.
So that materials having not such type of a problem.
Absolutely.
So we are studying about the niobium iron batteries.
I would love to learn more from you. And this
Okay,
is
thank you, sir.
Yes, thank you.
Okay. So thank you very much. Any other question from student side, please? Students, any other question? Okay, sir. I have one simple question. Especially India, people are not using the cell structure. They are using the pouch or maybe a kind of. So how your research is convert from the cell to pouch, where we have to be more kind of.
Good question. In general, it's very easy to switch from one coordinate system to the other.
Yeah.
Right? If you can solve a problem in cylindrical coordinates, in principle, you can easily solve it in other coordinate systems as well.
Yes.
The reason why most of our work focused on cylindrical cells was simply because of the nature of projects that we worked on. But almost all the work that we presented here can be translated easily to pouch cells. In fact, after we reported the axial and radial thermal conductivities of a cylindrical cell, other people all around the world have reported similar anisotropy in pouch cells as well.
So we did lot of simulation. So here is Sachin Gautam is here. But we consider the constant thermal conductivity in R and Z direction.
Right.
And I believe that whatever you put in a very nice way and like this. Suppose same things we consider in a XY coordinate.
Yes.
So XY coordinate, the thermal conductivity is again different?
Yes, so if I have a thin pouch cell,
Yeah.
then the out of plane thermal conductivity
Yeah.
is expected to be much smaller than the in plane thermal conductivity.
Okay.
So Z will be much lower
G
than
will be.
X and Y.
Okay.
Because that is the way the cell is folded.
Yes, yes.
You see?
Correct. Nice. So we have a joint working like a Dr. Sachin Gautam and we experiment simulation, all these things. He is a faculty in IIT Kharagpur. So thank you very much. Now, thank you, sir. So my request to our joint SY Professor M.K. Pandey, please come on stage. Yes, please. Please.
Thank you, sir, for your invaluable insights and an overall informative talk on the heat transfer methods in a lithium-ion battery. A huge round of applause and thank you for us, sir. Battery thermal technology is indeed a topic of exploration, and your talk has given a good insight on the topic. Thank you so much. As we present a token of memento for you, we once again thank you, sir. Now I hand over the session to our colleagues for the next plenary talk. Thank you.
Sir, I think next talk चल रहा है, next बात में discuss करते हैं.
Good morning. I, Soni Setia.
And I, Ujjwal Surohi, would like to proceed on to the plenary talk. We are privileged to have among us Professor Dr. S.K. Saha from IIT Delhi.
Now I would like to call our HOD sir and additional HOD sir to kindly felicitate Professor Dr. S.K. Saha.
Sir, please, come on.
Sir, please.
Sir, please.
Now I would like to call our HOD sir and additional HOD sir to kindly felicitate Professor Dr. S.K. Saha. Can we have a huge round of applause?
Please.
Thank you, sir.
Professor Subir Kumar Saha, a 1983 mechanical engineer, graduate from NIT Durgapur, India, completed his MTech from IIT Kharagpur, India, and PhD from McGill University, Canada. Upon completion of his PhD, he joined Toshiba Corporation's R&D Center in Japan. After 4 years of work experience in Japan, he has been with IIT Delhi since 1996. He is actively engaged in teaching, research, and technology transfer. He completed sponsors project and consultancies worth about rupees 14 crores. Professor Saha was awarded the Distinguished Alumnus Award for 2020 in Academic and Research by NIT Durgapur. He established the Mechatronics Laboratory at IIT Delhi in 2001. Professor Saha was awarded the Humboldt Fellowship in 1999. He was Narayan Gupta Chair Professor at IIT Delhi during 2010 to 20 and presently acting as Project Director IHFC, a non-profit company of IIT Delhi in the area of robotics. He has more than 200 research publications in reputed journals, conference and proceedings. Professor Saha is the Vice President Academic of the Robotics Society, formerly known as Robotics Society of India, and National Judge of the DD Robocom competitions in India since 2005. Sir, now I would request you to kindly address the gathering.
Thank you.
Hello, good morning. I'm really sorry for this thing, right? So please bear with us. जब तक वो एक बार टेस्ट करवाए ना मैं एक बार रीस्टार्ट करके देखता हूँ
घूमने के लिए
Okay, so my apology to all of you, and probably this is not today is not my day actually, right? And that's why things are coming on our way. First is the rain, the rain has made delay for you to come to me to pick me up, and then while coming from IIT to here, again such a heavy rain, it's like a push brishti, so I thought it would be my day. But coming here I realized this is not my day because my laptop has not connected. Anyway, so every situation has to have alternatives, and I think as an engineer we are all prepared for it, and finally we made it. So thank you for inviting me, and so thanks to Amity University. So I'm really pleased to be here. So the title of my topic is little different than what the classical would be. So I think students have found it not interesting, so they are all leaving. Okay. Okay, so that's why I said this is not my day today actually, right? So again the wrong timing. So anyway, doesn't matter. So the title is Robotics to Cobotics to Rural. So anything with R fascinates me actually. So robotics is one R, rural is another R. Someone has entered C. I'll tell you about C later on. But these days I work on railway dynamics also. So rail is another one. And as you can see, this is the 108th series. In fact, my daughter sometimes jokes with me, "Papa, तुम एक ही lecture बार-बार देते हो?" तो मैंने बोला क्या करूँ, एक ही तो चीज़ सीखा है एक्चुअली लाइफ में, राइट? जैसे सचिन तेंदुलकर का जब बैटिंग करते हैं, राइट? तो वो बैटिंग का देखने के लिए तो सब जाते हैं, राइट? जब वही शॉट देखते हैं एक्चुअली ना। तो मैंने बोला ऐसे क्लास बनाना चाहता हूँ, तो मेरा कोई लेक्चर सुनना चाहता है तो दे शुड कम फॉर दैट पर्टिकुलर शॉट ऑफ माई टाइम, ओके? Now the reason is 108 is people has to be repeatedly told, just like in childhood. My parents used to teach me, बेटा A लिखो, मैंने जो लिखा उसके ऊपर A लिखा actually, right? B लिखो, B लिखा, right? And until I have got the correct, I was not left out. So similarly, I have to repeatedly tell what my message is, right? Until I see someone, and nice to see Ankush here. I was thinking it might be Ankur, could be our students only, but now he just said, of course we are meeting probably after 20 years roughly, right? In between we made. So my interests are two. Maybe during my biodata, someone mentioned I didn't pay attention. I was thinking of my laptop, because as soon as they said your laptop cannot be connected, I was jerky, right? My weapons are gone actually from my hand actually, right? So how do I manage my show next 45 minutes? No? So I have two major interests. One is my right hand, one is my left hand actually. As you can see, the first one is called ROCB, Robotic Competition Knowledge-Based Education in Engineering. I'll tell you a little explain. By the way, as I said at the beginning, my topic is not a technical, it is more of philosophical, how a faculty and student can benefit from my experiences. So that's the experience sharing journey for next 40 minutes. So robotic computation-based education in engineering, and I consider itself as an innovative teaching methodology. Because our teaching methodology since 100 years or within 200, whatever time frame you think, gradually it is becoming worse and worse actually. Earlier we had, at least in my domain, we had a blackboard. So while the teacher is writing in the blackboard, students are trying to write something on there. So while they're writing, they're actually involving themselves to do something actually. Some part, 10%, 20% goes in their brain, right? But now what happens is, later on LCD projector comes, right? Oh, PPT to mil hi jayenge actually. Sir ko bol denge PDF de dena actually, right? Now that is very worse because first thing is PDF mil jayega soch ke to attention nahi de rahe, yahan Facebook chal raha actually, right? And then on the day before the exam, there is nobody to help. PDF तो है सामने 40 पेजेस तो है actually, right? But ये तो इक्वेशन ही पता नहीं, अब हमको जो सिखा रहे थे इक्वेशन उसको तो पता ही नहीं चल रहा अभी, किसको पास जाके सारे लगे हुए एक्चुअली, राइट, फाइट करने के लिए, राइट, किसको पूछा जाए, राइट? So obviously results are bad, right? So what is, and also at the same time, I will show you statistics in the next slide. 80% of Indian engineers are not fit for any job in the knowledge economy. It's 2019 statistics, okay? But this has not improved much drastically. Maybe 80 might have become 70 or 65 because of the emphasis from the government side. The skill badhao, skill badhao, skill badhao, right? Skill India, stand up India and all these things. And there are lots of effort. With that, there are improvement happened. And we are also engaged in this. I'll share some of our experiences as well. But this is very alarming situation because India is one of the youngest country in the world. And imagine all सारे जो population जो है अभी जितने बच्चे बैठे हुए थे यहाँ पे, let's say if they are not unemployable for example, क्या करेंगे? छेड़छाड़ करेंगे, right? इधर-उधर करेंगे, right? So it will become a liability for the society, no? So we have to think how to make them, engaged or industry ready, right? So that's the idea. So through this ROG-B concept, when they learn by doing it actually, so they will be more valuable for the industry or for the society. The second part is my second interest actually, is a mudra, multibody dynamics for rural applications. Multibody dynamics is my bread and butter. If someone asks me what is your research domain, I call it's a multibody dynamics. In fact, we have a conference coming up in October, I'll tell you at the end, so whoever interested can take part. So multibody dynamics typically used in designing aircraft, spacecraft, car, automobiles of various sort, which moves fast, and you wanted to predict its behavior, modeling and simulation and use for design, ADAM software, Rickerton software, VI Rails, right? So all they do like this, right? But now how do we apply for the rural application? Because in rural application, for example, I'll give you an example here. So here you see a pedal pump, leg operated pump, right? Now in this pump, there are a lot of difficulties faced by the villagers, and they came to us, can you improve the performance of it? So we did certain improvement, but we thought that if we apply multibody dynamics knowledge, we can do even better. And for your information, difference between design in so-called high-tech or advanced technology versus rural technology is, if all of you are mechanical, right? Mostly mechanical engineer, right? So you know cantilever beam versus fixed beam. Cantilever beam can bend one side like anything, right? So one side is, so high-tech designs are like a cantilever beam. You have only objective is the optimization or make it more efficient. You don't care what is the price is, right? What is the price is. But here it's a double-sided fixed. Now you have to make it optimum, at the same time cost has to be also restricted actually, And we know this is an over-constrained system, so it's a more difficult problem even in undergraduate level, right? So solving rural problems, whether dynamics or not, so if you do the dynamic, you can predict its behavior much before you really implement in the field, right? So that way it is much more difficult, and I call it an innovative research, because America has not started this research, because they don't need it actually, So if they need to implement it, there's a big land, big money, they देंगे $10,000 क्या फर्क पड़ता है? हमारे पास 10,000 रुपया भी है, हमारे बच्चे, rural people will not be able to pay actually, And anything in India, unless it is Americanized, it is not fashionable actually, तो इसके लिए हमने भी थोड़ा सा शुरू किया अमेरिकनाइज करने के लिए. तो एपिक्स इज अ प्रोग्राम एट पार्डू यूनिवर्सिटी. तो वहाँ पे भी रूरल काम चलता है, तो इट इज़ कॉल्ड इंजीनियरिंग प्रोजेक्ट्स इन कम्युनिटी सर्विस। उनको साथ भी दोस्ती बना रखा है, जस्ट टू कीप इट ऑर्नामेंटल, टू बी वेरी ऑनेस्ट विद यू नो। हम अमेरिका से डिग्री करके आया तो हाथ तो बहुत ज्ञानी बंदा हो गया, राइट। तो इसीलिए मुद्रा जो है कॉन्सेप्ट, इफ इट इज एपिक्स कनेक्शन इज देयर, तो इट विल हैव ए बेटर ब्रांड वैल्यू, नो। लेट्स एक्सेप्ट द फैक्ट्स। Okay, so this one I have not showed you. इसका वीडियो क्या है? So this is a mobile robot in 2020 in a hospital. It has been utilized during the COVID time, and the company is called PR Robotics, PWR. One of our students, very young, 2016 graduate. So he started this company in Gurgaon, and now he has a US counterpart because there are lots of money floating there, so he wanted to pick the money from there. But this robot actually is an evaluation of students taking part in a robotic contest called Robocon. And Robocon, we have been participating from 2003, so several evaluations have brought him to this level, you know. So that's why I call it robotic competition-based knowledge in engineering. So he come from that knowledge to the product level. No? It's a complete value chain cycle of an industry has been demonstrated. Okay? And Robocon this year we have conducted at Delhi, 16th, 17th of July, and the international competition we again will be hosting it on 21st of August. So if you are interested to see, you can come to Tyagaraja Stadium. It will be free of cost. You have to just register the online, aburobocon.com. And you can come and enjoy the festival. Just a brief, mechatronics lab we started in 2001. So I have one video here as a part of what you see here is a motion platform. It's a steward platform in robotic terminology, also people call it, or parallel robot. It has a chassis, a truck chassis on the top of it, you know, and the driver can take a training. You know. For your information, every flight simulators give a training to pilots before they really fly a plane actually. You know. So Indian Army, they have a simulator development division, SDD, in Secunderabad. So they wanted to give the training to their drivers, simulating various situations like Siachen or all difficult to reach terrain, because sending a person, giving a training is very expensive and time consuming. No? So they thought this kind of simulator would do the job. So we have designed this thing and a Gurgaon-based company has manufactured, and finally it was delivered to them. However, such systems have many other applications. Uska chota bhai jo hai aur beta jo bhi aap bolna chahenge, we have used in a medical implants, etching purposes. You know? So this is a 500 gram capacity, the same architecture, only scaled down version. थोड़ा कलर वगैरह change कर दिया सुंदर लगने के लिए, otherwise it has no other meaning. So you can see there is an implant here, which goes inside the body. Our biomedical engineering professors wanted to do some etching in a very accurate manner. So we proposed this device and finally it will be implemented. So etching is a small laser spot, as you can see, it makes small potholes. And when it goes inside the body, so the fluid makes more lubrication effect, so you don't get the pain once it has been inside the body. So 2001, we started journey of mechatronics. Then 2010, we could attract a big funding, almost like a 7+ crore from Bhabha Atomic Research Center to develop technologies for automatic assembly of fuel cells. And I will show you, and we call it a program for autonomous robotics. So this is one contribution from our computer science department. So immersive environment for teleoperation. So robot is remote location. In this case, of course, it's about 10 meters away. And the operator is looking at the screen on the virtual robot. So this is a virtual robot. And he's trying to control this robot. And the real robot is actually on another place. By controlling the virtual robot, whatever signal goes to virtual robot, the same signal goes there, but the operator has a time to correct in case there is something wrong is happening. Immediately he can correct actually. And more importantly, you cannot see the real robot there if it is in a very difficult to reach place. In a way, if it is a nuclear radiation is there, you don't want to go there. So that's the idea. And this is also called augmented reality. You might be hearing this term these days, AR, VR, augmented reality, virtual reality. So this is one such application. From mechanical point of view, we did the mechanical assembly of a peg-in-hole operation, it is called, because fuel cell its diameter is about 10 millimeter, and the tube which has to go is 10.01 millimeter. No? So before that, we are demonstrating here a compliance. Means robot should be listening to my force, not that it should hurt me back. Most of the industrial robot, if you go to Maruti and other plants here, they are all inside the cages. If you go, it will stop. So taking these compliance aspects, so you can see now this is a peg-in-hole operation. So you can see a cylindrical diameter is getting inserted in another cylindrical hole. Because the clearance is very low, by observation you cannot put it. Just like you imagine when you open the key of your door, what you do? You just don't see and do it, right? You will not be able to do it, 100%, right? So you go nearby and then do this kind of thing, search, right? So robot is also doing a searching here. It's called conical search, and wherever it finds the direction of the hole through the mathematical calculation in the background, and then it inserts. Okay, as I said, we are Indians by citizen, by birth, but हमारा मन तो उधर पड़ा रहता है actually, no? उधर मतलब पैसिफिक का उधर, right? हम अमेरिकन के बारे में ज़्यादा जानते, यूरोपियन के बारे में ज़्यादा जानते, इंडियन के बारे में not that everybody are same, but general बात बोल रहे थे, right? तो here I took a chance, मैं इंडियन रोबोट के बारे में ज़्यादा बताऊँगा यहाँ पे, right? So this is the Indian robot I told you at the top, the PR robotic. The second one at the bottom is in Greater Noida. This is one of the very famous, in last 7 years they become famous, Adverb Technologies. So they have attracted $300 million from Reliance 2-3 months ago. Gray orange, many of you might have heard. So Adverb is also in warehouse automation. With the money from Reliance, they are going into the medical robotics. And gray orange, again a warehouse automation. I've been told that they are now considering business in more there. But the Milagro is another company who makes floor cleaning robots. Defense and social robots are by the defense laboratories. The DRDO has made ducks, the bomb disposal robots. And then there are Netra. All of you have watched 3 Idiots. So this is the evolution from the 3 Idiots. So it's called Idea Forge. For the industrial robots, there are companies like MTAP, Machine Tool Aidsboro in Chennai, and Tata also started a company called TAL, but now they have merged with Telco, or not Telco, Tata Motors. Talking about other robotics, Newgenics in Maharashtra is another company, and then this is the CARE, Center for Artificial Intelligence Robotics at DRDO Lab. They made a working robot. This is for underwater robots by CMA Durgapur, and then this is a Systematics, a private company who makes this robot for the SCADA. This is a company in Gurgaon again. You heard of your Da Vinci, which is a 25 crores worth things. So this guy, SS Innovations, he returned from US, he's a surgeon, and he wanted to give a challenge. He wanted to produce this medical robot with the 5 crores. Then the bottom is a company for educational robot, SVR Infotech. They make small robots plus softwares as well. Now coming to the robotics as a topic, you must learn about kinematics, dynamics, control and simulation. And in order to make these things available, so I wrote a book in 2008, that's Robotics, Introduction to Robotics, and the second edition came out in 2014. And when we wrote the book, I wrote the book in 2008, I got a feedback 10, 11 that the mathematics which goes after chapter 5 is rather difficult for many to understand, right? So then we thought of getting, now I will not be able to show this demo because it is not my laptop. RoboAnalyzer is a software we have developed which can give you, easy understanding of what forward kinematics means, what inverse kinematics mean. And it can be done in few seconds rather than spending hours, to explain the meaning of those things. So this is one of the unfortunate part of not using my own laptop, but doesn't matter. You can download it. Up to 8.0, it is free of cost. 8.0 and above will be paid. So a company has taken a tech transfer a few months ago. So now he's selling it and he's conducting workshops. And as he told me last week only, maybe in Northern Zone he's going to conduct a workshop very soon. If Amity is interested, Amity can also organize through them. But I think here they're talking to Manabarashna most probably. Maybe in the month of October, November they will do it. So all zones they are doing to go this thing. But getting inspired by the RoboAnalyzer success, actually, we started doing Mechanalyzer. So for those who are teaching theory of machines course, they can download this Mechanalyzer. Mechanalyzer is completely free at this moment. So mechanalyzer.com you can download. So 4-bar mechanism, what is inversion. So these concepts can be very easily understood. Gear profile making. So students sitting at home also can understand these concepts if they are missed some points at class. Anyway, a screenshot is there for the RoboAnalyzer. So this is, for example, a default screen comes. So this is like a two-link robot arm. It's like my upper arm and lower arm. And if you do forward kinematics, it will just show the animation like this thing, right? So forward kinematics means moving this joint and that joint, how the end effector will move, okay? Then we have some standard robots, 17 or 18 of those things. So it is good for ITI and diploma holders before they go to the real workshop training. So this software training could be good. So that's about robotics actually. Then robotics become cobotics. Cobotics means collaborative robotics. So if a robot and human being are working in the same environment, then we call it a cobotic system, right? Why cobotics is important? Because only robot becomes very expensive. Robot is a robot and then it has to make a fence. One cannot enter, so all the safety precautions, all those things. So people started thinking that why not human and robot can start working together. But then if they work together, then some of the other aspect has to be taken into account, and that's my next slide. So this is some typical definition of those things. And Government of India, our Minister of Science and Technology, has provided us 170 crores to create products for next 5 years, and it has to operate as a non-profit company called IHFC, or I Have Foundation for Cobotics. So we have 4 major mandates: research funding, startup funding, skill development, and the international relations. All 4 dimensions we are going very strong, compared to another 25 technology innovation hubs in the country. So if you talk about research funding, we have already given to 23 institutes. It's a national property actually. It's not IIT Delhi's property. So we have given 23 institutes working on rehabilitation robotics, healthcare robotics, medical simulation, drone technology. We are going to come up with a drone technology park in our Sonipat campus. Within the next 6 to 8 months' time, you will be able to see, you will be able to get a training, you will be able to validate. If you have a technology, you can come to us validate. If you have a good company who needs the support, funding, we can provide the funding. So if you have seen 29th of January this year, the 1000 drone show by Botlab Dynamics, so we have a 50% funding to that company, in that project, right? And now they are planning in a even bigger way, So that is our funding part. Startup funding I also mentioned. The third one is skill development. So we have reached out to school as well. So Delhi School Board has a new board called Delhi Board of Specialized Education. So 9, 10, 11, 12, we are making their course on robotics and automation. And we'll be helping them to open about 200 laboratories in next 3-4 years' time. Similarly, we ICSC board, we have written the course for robotics and AI, and now we are running several courses. One from BSF will be running a drone technology. So Amity would have a lot of opportunities to work, if not directly with IIT, but through this company we'll have a lot of scopes because we are independent entity. We run by company affairs governance rules rather than IIT rules actually. Just to tell you the example of what a cobot means. So here is an example of cobot. So one of my ex-PhD student using a cobot by...
ऐसा लग रहा है face से बहुत ज़्यादा ताकत लगा रहे हो सर आप. थोड़ा smile.
He's teaching the robot how to trace this line. And after basically he's teaching, right? That, as I told you at the beginning, ABCD writing, my mother taught me. So he's teaching this guy, draw this thing, and after that he will say, okay, do it again. And then, so earlier, or rather formally in the robot, you have to do the robot programming, go A, O, B, and whether it will run or not, then you have to do the offline simulation first. रोबोट पे जाएंगे तो करेगा कि नहीं, चलो डरे हुए हैं ना, करेगा कि नहीं करेगा, होता तब emergency switch दबा दिया. But here you are teaching it, so and the robot is actually recording those things. So that's the beauty of cobot. So learning time is much faster. Even a non-engineer can do the programming because the operator चलो ऐसा करो, कर दिया, right? Done. So you don't have to have an engineering degree for that thing, right? So that's the reason. Human intelligence or human intuition and the machine's ability. So if you can make the machine little smart in that sense, so then, and particularly for a country like India, it will be huge benefit actually. We don't want to displace people from their job. उनका जो skill है, experience है, उसको हम काम पे लगाना चाहते हैं, ठीक है? As we've seen, it has done the job. Another example in medical, it's a tripartite collaboration. Please watch first. So this is a universal robot. One of the companies have bought for us, and my PhD student worked on the control algorithm, and AIMS has provided the testing facility. So it's a teleoperated ultrasound. During the COVID time, it was very important. It started that time. So we wanted to take this technology to even the villages also. In Uttarakhand, there is a huge requirement for liver scanning or the kidney scanning. But there is an act called PNDT Act, Prenatal Sex Determination. You cannot install ultrasound wherever you like to. It requires a permission from the government of India, and they're very strict in that case. So this technology we are looking if it can be taken outside where PNDT kind of act does not exist. Otherwise, so far the boy has been doing pretty well. He has gone for exchange program to Purdue, by the way. So this is a doctor's site, Dr. Chandrasekhar. Now he operates from the first floor, and the machine is in the ground floor. In this, the beginning, it was in the same floor. Robot versus cobot, I have given enough, but this diagram would depict. Robot means it has to put in cage, and these are the difficulties, and cobot means it can work together. Some of the technologies, and some of the technologies we have developed as a part of program for autonomous robot. We have come up with a book called Vision-Based Identification and Force Control of Industrial Robot. So this talks about how we have implemented. It's a complete practical experience has been shared in this book. Bot lab dynamics I just mentioned.
क्या केवल एक भूखंड, जमीन का एक टुकड़ा, या उस देश में बसे लोग, उनकी सभ्यता, संस्कृति, संस्कार, उनके मूल्य और विश्वास। जब हम भारतवर्ष के मूल तत्व को खोजें, तो मिलता है सत्य, अहिंसा, प्रेम, सहिष्णुता।
So those are the small dots. Actually, they are called nano drones. Nano doesn't mean 10 to minus 9 here. Nano means the small drones, right? So they make the formation. So this is a 1,000 drone show. So they have shown the India map and the globe and everything. And recently they went to the country called Djibouti. It's in East Africa. For their 45th independence celebration, this company went. And yesterday, the owner has shared me a confidential thing. So next Republic Day के लिए भी request आया है to make a much bigger show. So we are very busy. Because for my international RoboCon, I was telling them, can you make a show? Because we have 5 minutes introduction video. So he says, sir, आपके लिए कर देंगे, but don't ask any other things actually. No? But then the other activity related to the drone, here is the drone manipulation.
Sir, could you hold the phone, sir? I have to take it.
So drone now has an arm at the end of it, and once you put an arm, it becomes more difficult to control. So I'll go a little fast forward for the sake of time. So also on the Republic Day, in front of our director, we have showed this demo. It's a collaboration with the 5 institutes, 2 IITs, IIT Delhi and IIT Roorkee, and 3 national labs, CD Pilani, CSIR NAL, Bangalore, and then 3 made Durgapur. So it is about 150 gram payload to take medicines and stuff like that. That was our idea. When you talked about cobotics as a company, we run monthly seminars. So every second Wednesday we'll have a cobot talks between 6 and 7 p.m. online. So next one will be on the 10th of August If you are interested, 6 to 7, you can register online. You will get the invitation, again free of cost. So on 10th, Professor Sunil Jha will explain how we have conducted the RoboCon this year. It was a very difficult and grand show. 800 students came from 43 places. Unfortunately, Northern Zone had no participation except one from Ghaziabad, right, which is AKG. And this is my earnest request. It is a property of Doordarshan. It has been held at Pune for 16 years. And so if you look at the places in the country, if you draw a vertical line from the country, north to south, 41 teams came from the left-hand side, Maharashtra and Gujarat mostly, right? Some from south. And from northern zone only AKG, and from the eastern zone there is a college from Odisha came, right? So I would request mechanical head and all other people at Amity, you are such a brand name, right? No, you should have at least 5 teams actually, to taking part. And we'll be conducting up to 2024 in Delhi, certainly, because we have now MOU with Professor Bharti. So please do take part. And Professor Bharti brought to North in 2019 to encourage students to take part. And here I have a request. You do go outside, I know, and students love to go outside because free brand value aa jata actually, right? But not at the cost of home. All colleges have a large number of students. Some students go abroad, it's fine, right? But is it at the cost of home, right? घर का बच्चे को छोड़ के दूसरे बच्चे को adopt कर लूँगा क्या actually? नहीं ना? ठीक है, if I have money, I will adopt another one from another place. But of course, मेरा बच्चे को तो ख्याल रख ही करूँगा ना? तो if you are going outside, you are actually enriching their competition. Because वो क्या बोलेंगे? हमारा तो इंडिया से भी participation है, right? But then if you are neglecting your, हम क्या बोलेंगे? अरे इंडियन competition में 10 टीम आते हैं mostly actually, क्या फायदा ना? तो if you complain about Indian technology, you have to be careful about these attitudes actually, okay? So please do take part, and we put a lot of effort, and this is a lot of skill development activity. If you ask any student in this campus that robotics club है तो कहाँ से खरीदते हैं component, majority will say robo.in. And robo.in is a startup company from MIT, Pune, Maharashtra Institute of Technology, जिन्होंने RoboCon participate किया था 10 years ago actually. So you can see that is the brand it has created. So here is a glimpse of net. I'm not sure net is connected or not, maybe not. So let's see 2019. Otherwise I could have thought 2022 itself. So how was it in 2019? Got a glimpse of it actually. So these robots have been done by the student. They've been conceived by the student, designed by the student, made by the student, debugged by the student, and finally they came for the competition, right? And not necessarily the best robot wins, because in this game 2019, Nirma University had the best robots actually, but it was LJ College in Ahmedabad who won. And the philosophy for them was slow but steady wins actually, वो हड़बड़ी कर रहे थे निर्मा वाले ने, so they couldn't lose, right? So this year being host, India being the host, so we have chosen the theme as a Lagori, Pit to 4 the game, So I can give it a try. If net is connected, it may go directly to the YouTube and to show you. So we have adopted the game, and domestic was shown live in Doordarshan and YouTube as well. Good. And so the international will be also shown YouTube certainly. I'm not sure the Doordarshan will play live because it is an international game, how many will take interest. So aburobocon2022.com आप जाएंगे तो इसमें so you can see, so this is the game theme, So I'll just play for a few seconds. So, okay. There.
Move in red area, and blue team can move in blue area.
And the robots have
Each team area has R1 and R2 start zone with a penalty zone where a part of robot must not stay for more than 10 seconds. There are 2 ball areas in the game field, each with 3 hitter balls are placed on the ball racks before the round starts. Lagori is a tower with 5 cylindrical discs to be placed on top of one another on a square base.
Fast forward.
Each team will play game and understand the Lagori game played by the robots. When the setting time is over, the game will start with the start of round 1 for 90 seconds. When the round starts, Seeker R1 throws Seeker balls to break the Lagori. However, Seeker R1 can throw the balls only when all of its contact surface with the field is in the R1SZ. Seeker will score points according to the number of the broken Lagori discs.
Okay, so this was
Seeker
the
gets
theme.
5 points for each
So all 18 or 12 countries have played the same game theme, and on 21st they will play. Unfortunately, they are not coming to India because of restriction in their countries, but you will be seen in a big screen, so it will be screen of this wall, almost half of this wall. So we have to judge sitting in Tyagaraja Stadium. Only 2 of our finalists will come, one from Pune, one from Ahmedabad. And please come with a large number because the stadium of 4,500 capacity otherwise look very empty. So please send all your students to enjoy. So the next year they would know that what is the way to participate. And next year competition actually will be hosted by Vietnam or Cambodia. And the game plan will come from them. And 21st of August the game plan will be out. Now after going through this Robocon experience 2003 to 8, we realize what is its reliability. If it has to become a product, so what is its reliability, no? So this is the first test we have given to the students.
Press the red button, enter passcode 1, 2, 3, 4, 5. Press red button again.
So this was kept in the student activity center unattended 24 hours to give the students understanding what reliability means. They said if it can work unattended 24 hours, 7 days, you have a very good reliable robot. Otherwise now. This is one of the robots who participated in 2008 Robocon, converted, and all the difficulties we faced. We gave a project name as RoboMuse. RoboMuse 1, 2, 3, 4. Finally 5, as I told you, it has been adopted by that PR robotics. Okay. Briefly, I'll touch upon, there is not much time is there. So they're coming to rural sector, as I said, no, 80% people lives in the villages, right? If you're not doing anything for them, it is a crime on us actually, right? So my first exposure was related to the carpet technologies, a place called Bhadohi, 40 kilometers from Varanasi. And I have asked an exporter's son, fortunately he was at IIT Delhi, and I was his kind of a mentor, and I asked only in the hostel meeting, भाई तुम्हारा घर कहाँ पे है? बोलता भादोही में। भादोही कलते ही मेरा दिमाग थोड़ा सा अलर्ट हो जाती है। तो ऐसे पापा क्या करते हैं? बोलते पापा तो एक्सपोर्टर है। अरे बढ़िया चीज़ है। कारपेट वीविंग देखा है? हाँ देखा है, सामने से देखा है, नहीं दूर से देखा है। क्यों? नहीं, हमारा पापा मम्मी ने बोलते थे जे दियावर का उस तरफ मत जाना, फैक्ट्री का मत जाना एक्चुअली ने, तेरे को पढ़ाई करना है, आईटी में एडमिशन लेनी है एक्चुअली, तो उधर क्यों नहीं जाओगे? नहीं बोलते वो जाएंगे तो खराब हो जाएंगे एक्चुअली ना. But the machine in front of you is actually mechanical engineering, right? So it has a structures basically, as you can see, right? And if he is not paying attention as an engineer, if I am not paying attention as a designer, then who else? Do you want that class? No education person will do it. Obviously, technology ऐसी रहेगा actually. And if you don't do it, already America, UK, Japan are already in the social sectors actually. You know, they are going to various countries to pick up those problems. और काला परसों आ जाएंगे प्रोडक्ट लेके, तब हम चिल्लाएंगे हाँ बस बढ़िया हो गया ना, हम तो अमेरिकन अडॉप्ट कर लिए, right? So I have a demo, because of time I'm not showing it. If I give you a demo in Google search, carpet loom design, which is in front of you, मेरा paper first दिखेगा actually, right? But if I put robot design, robot dynamic analysis, मेरा paper तो पहले 10 पेज में दिखता ही नहीं actually, no? What does it mean? If you start something fresh today, you will be the leader. But if you start 20 years after, you will be follower. तो हम तो follower होते जा रहे हैं actually, ना? हमको leader बननी है तो you have to start something different, no? That's the idea. So when I took it to various professors and students, सबको professor कभी कोई बोलता है अच्छा इसमें क्या challenge है? राइट एंड स्टूडेंट बोलता है जी सर मेरे को तो अमेरिका जाना है एक्चुअली, आपका रोबोटिक्स वाला प्रोजेक्ट मेरे को दीजिए एक्चुअली, नहीं बिकॉज इट्स नॉट फैशनेबल. तो इसको फैशनेबल करने के लिए वी डू आस्क देम टू यूटिलाइज एफई सॉफ्टवेयर्स सो दैट जो भी डिज़ाइन होगी यू कैन वैलिडेट. So from my side, research and validation. So we did some optimization for PhD student, and now it is 10 to 25% less cost. Next one is the cleaning. So this is the way cleaning is done. So we made the machine here. Briefly, you can watch the machine. And so this is the illustration of the machine. But the same machine was utilized by an Italian professor for walking leg, as you see on the top, right? So it's like a character ABCDs. You can utilize in whatever domain you like. So at IIT Delhi, we run a program called RUTAC, Rural Technology Action Group. There are 7 IITs have this program. And this is a program for Principal Scientific Advisor's Office. And we are working these days as a spoken hub model. If MIT is interested or any university is interested, they can pick up problem for us. जो भी खर्चा वगैरह होते हैं हम पे कर देते हैं एक्चुअली. एंड जो भी एक्नॉलेजमेंट चाहते होते, फॉर एग्जाम्पल प्रेजेंटिंग ए पेपर इन अ कॉन्फ्रेंस, वी मे पे टू दैट स्टूडेंट और फैकल्टी. So there are many of those things are there. I don't know which one to show you. Maybe this one. So Tulsi, again it will not work because link is not working. So this is furnace. This is for farming, bullock-driven tractor, treadle pump. This is to remove from the ship's body, ship sharing device. This is for the Tulsi Mala bead making machines for Mathura and Vrindavan. This is for the water measurement development. This is another project we have taken it for the vending cart जो ठेला चलाते हैं ना, तो उनको लाइफ थोड़ा सा easy करने के लिए. So we are trying to increase the space, putting lights, and this is called lift and turn, because if you have seen how do they turn. So we have added a mechanism there. As you can see, this guy is turning so easily actually, no? So this will be act as a modular. If someone can afford to do this thing, maybe 5,000, 8,000 add karke, they can add it, no? And then mobile app. So to see whether the food and vegetable, basically to create social projects for computer science people as well. No, people think computer science के लिए project valuable नहीं है actually. No, look at the vegetables, fruits, and see whether good or bad. You use AI, ML, very hot topic these days, right? So we do interact with many people at GNU, DTU, IIT Indore, IIT Jammu, and all those people. Epics I did mention. And this is some Epics video. Every 2 months we have an online meeting. We are running summer internship with our students. Last year, as you can see, 500 showed interest and 184 finished. This year, 200 are doing it, but you can see the feedback. Really enjoyed the fact that there is no spoon feeding, and we worked on our own and built things. Great learning experience and help to find new friends. This is the 2 invitations I wanted to make it. The bottom one I already mentioned it. ABU Robocon 21st is just 15 days away. Sunday from 9 a.m. to 2 p.m. The activity will be happen. So if you wanted to come physically, you are welcome. This is for the researchers mostly. There is a conference coming up October 16 to 20, and our early bird registration is extended up to day after tomorrow. So in case you want to take advantage, please do come. There were 200 plus people will be joining, and many, about 50 plus from Asia and America and Europe. So with this, I want to conclude saying that Robocon has an experience of innovative learning. I have explained new direction as a cobotics, as a IHFC, as a company you can interact, and RUTAC as a way of connecting young minds with the society. So through these exercises, you are actually connecting young minds. नहीं तो क्या situation होगा? No, maybe someone will go to America and दोस्ती बनाएगा कोई white बंदा के साथ, बोलेगा अच्छा तुम नोएडा से हो? I was in Noida for 3 weeks. What did you do in Noida? No, I was solving that. वो जो पानी का problem है ना, तुम्हारा water है क्या problem? So that will be shameful things to be experiencing. It's like going to someone's house. कितने भाई बहन हो तुम? 2 भाई बहन हो actually. अच्छा भाई का बड़े भाई का क्या नाम है? बड़े भाई का नाम, बड़े भाई का नाम. एक मिनट मम्मी को पूछ के आता ना. It should not be feeling like that, right? Anyway, acknowledgement to all our friends, students and staff, and finally, thank you, and that's my website, email, and my mobile is public, so you can use it within the public time, okay? Thank you very much.
Thank you very much, sir. Any question from student sides and participant side? Yes. Use को लेके जाना.
वो लेके जाओ। हाँ, उधर उधर, अच्छा पीछे पीछे बोल।
I'm not asking question.
Who is asking question?
Sir, he is not asking question.
Yes, sir is asking something.
Please. Hello, hello.
Very nice presentation.
Thank you.
Dr. Saha. Great. So really robotics is entering in the agriculture field is a great extent because we are all depends on that particular phenomena. So more work, from my side point of view, more work to be done in the agriculture.
100%, 200%, right?
So we should all here as a technical expert, technology expert, should join hand to do this something in the agriculture fields.
Thank you.
In this form of robotics, mechanism, or band mechanism, everything. Thank you.
मैं थोड़ा सा एक्सटेंड करना चाहूँगा एग्रीकल्चर के साथ साथ नॉन एग्रीकल्चर को भी जोड़ लीजिए बिकॉज एग्रीकल्चर के लिए तो 30+ इंस्टीट्यूट एग्जिस्ट करता है डेडिकेटेड ICR के अंडर में नो जो एग्जिस्ट नहीं करता है नॉन एग्रीकल्चर के लिए फॉर एग्जांपल पॉटर्स के लिए राइट कुमार्स के लिए राइट then like for them there is nobody to look after actually you know so Rutak actually started with that kind of mandate और उनका हमारा जो PSA ऑफिस से आया था इंस्ट्रक्शन बोलता नॉन एग्रीकल्चर कोई टारगेट रखोगे ज़्यादातर but some of the machines have come in such a manner which can be utilized in both sectors no so दोनों को ही लेके चलेंगे actually right thank you
right.
Any other questions? Yes. Yes please.
सुन रहे
yes.
Sure. Yes, yes. Yes. Yes, 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 yes. Yes, 100%. No, whatever way you want to. आपने जो कहा है ना, this is our mental barrier. मेरा को ये सोच होता है मेरे को जो if society has done something and if I'm not doing anything wrong, I can break it. Just to give you my experience, जब मैंने assistant professor join किया था 96 में, so I was looking for interacting with the students, right? तो पहले क्लासरूम में जाके डिज़ाइन क्लास आई डोंट नो whether आपको दिन में डिज़ाइन क्लास or not. तो आई यूज्ड टू टीच नो डिज़ाइन और उसमें ये सब बात करते थे एक्चुअली नो सोसाइटी नो ऑल दिस थिंग्स सो कॉल्ड फिलोसॉफिकल बात तो लगता था स्टूडेंट का मन में ये होता था आज ना ये पढ़ाई करके नहीं आया है इसीलिए ये सब बात बोल रहे हैं राइट So then I realized classroom is not the best setting up. So I was looking for a forum and then SE club, no, SE US was coming very large way. तो IIT दिल्ली में आया मेरे हेड बोला जो करोगे इसको गाइड करोगे तो मैंने बोला अच्छा चलो ठीक है स्टूडेंट के साथ इंटरेक्शन का मौका मिलेगा तो पहले एसी क्लब शुरू किया था राइट व्हाट आई एम ट्राइंग टू से इज पहले एसी क्लब 5 साल चला फिर रोबोटिक्स क्लब आया देन एसी को छोड़ के रोबोटिक्स में आ गया एंड दैट टाइम आई हेड ऑफ द डिपार्टमेंट से साहब तुमको प्रमोशन वगैरह लेनी है कि नहीं लेनी है एक्चुअली तो मैंने क्यों बोला ये तुम स्टूडेंट के पीछे भागते रहते हो कॉन्फ्रेंस करते रहते हो तो देन रात को मैंने सोचा मैंने कि प्रोफेसर बनने के लिए इधर आया हूँ कि और कुछ करने के लिए आया हूँ राइट सो व्हाट आई एम सेइंग इज हट के कुछ काम तुमको लगता है जो सही है एक्चुअली ना यू शुड इनिशिएट अनदर एग्जाम्पल आई वांटेड टू इंटरेक्ट विद अ यंगर किड तो आई वेंट टू माई टाउन एंड आई वेंट टू माई स्कूल राइट जहाँ पे मैंने क्लास 10 तक पढ़ा था एंड फर्स्ट डे में जाने में थोड़ा सा हेजिटेशन लग रहा था अरे पहचान के नहीं अभी तो आजकल रेगुलर हो गया फ़ोन में भी बात होता है हेडमास्टर के साथ एक्चुअली अच्छा आपका बच्चा क्या कर रहे हैं अच्छा कुछ चाहिए हेल्प चाहिए नाउ दे गॉट ए होटल टिंकरिंग लैब फंड फ्रॉम नीति आयोग 10 लाख की तो बोलते हैं प्रोफेसर साहा कैसे आप हेल्प कर सकते हो मैंने चलो गाइड कर दूँगे यू सी हट कर करो ना यू कम द सोसाइटी इज जनरली रिसेप्टिव एक्चुअली ना हमारा मन में होता है कि ये लाइन है या ना नहीं हम भी गाँव पे जाते हैं एक्चुअली ना दिक्कत होती है वो बोलता है कौन अमेरिकन बाबा क्या अंग्रेजी में बात कर तो यू कम वी विल हैव अपॉर्चुनिटी
थैंक यू.
Yes.
Sir, you have reached to the doing and you are solving the problem for the carpet industry, sir. I feel that now with the 25% defense R&D funding to all the academia and industry, you can play much bigger role in defense industry also, sir.
If they are interested to take my services, yes, why not? But they are not unfortunately taking. They thought I am not competent enough to do this thing, right? तुम्हारा जो ये project चल रहा है ना, humanoid robot,
yes,
humanoid soldier project जो है, that was initially discussed with me only at IIT Delhi.
Okay,
right?
sir.
There are several meetings were conducted. There are international workshop was conducted by our group only in 2020 January. But when the money came, they are not interacting with us. क्या करे बताओ अभी? Right? So you can take it to the appropriate forum and to see how this is, right?
There Rahman sir is there, no? We'll talk.
Yeah,
to
so
them.
please talk to your concern. We will be happy to contribute and we are ready to contribute actually. In fact, we said IHFC even poured in money, right? We have 170 crores, right? We can even pour 10-20 crores on that also, right? So please, so you talk, we are all eager to contribute, yes, because we are talking about nation, right?
Yes, thank you, sir.
Any other questions?
Sir, good morning. I am from DRDO. I just want to ask those servo components which you are using in these robots, like motors, encoders, and all these things. Is it indigenous or you are procuring from outside?
Motors and some of the ICs, they are mostly imported if you make a good company. But the devices I showed you actually, like the Stewart platform and everything, and I think we bought it. I don't remember. It's about 15, 16 years old. So they are maybe domestic also, or I don't remember exactly. But as you were right, precision component, it has still, I interact with the company, they said motors and ICs still have to be imported. India doesn't yet have that much reliable and economic motors.
What about encoders and resolvers?
Those are available. Though I don't know what precision you are talking about, but up to certain level they are available and they are way out also. Okay. If you do not have a very sophisticated hardware, you can compensate with the software. We are very good at software, no? That's so everybody knows, right? The compensation to software is possible. Like for example, I'll tell you that KUKA robot, you have seen it. The precision 0.01 millimeter, the clearances we could insert. Whereas KUKA has 0.1 millimeter accuracy. So what we did a sensor integration. So he had a 4-stroke sensors, he had a vision sensors. So combining the informations together, we could even reach up to 0.01, even though KUKA robot itself has only 0.1. So there are way around to do things. For example, again, KUKA does not allow, industrial KUKA does not allow force control, right? But my student could manage to do the force control because while he is going through the maintenance manual, he found out that for the maintenance repairing purposes, one can check the current of the motors. And now he is using that current as a sensor and trying to control it, So there are ways around. If we can work together, I'm sure it can do the wonder actually.
Thank you, sir. Thank you very much.
Yes.
Thank you. Any other question? So sir, I just share, I met to Sarita Helawat,
Yes.
Bot Lab Dynamics. So she's agreed to help us. We have here the drone club. So she's agreed to help us, our
Very
drone
good.
club, and
Right.
she will be come very soon. You know that she's very busy. I think she's
Yes.
now in a meetings here. So
Mhm.
she's supposed to be here
Chalo,
today.
very good.
But sir, definitely your expertise like robotics, all these things. So our department has a robotics club, and definitely we associate with in a robotics
Sure,
club.
sure.
We
Right.
take the training, whatever the online, all these things,
Right,
and
right.
whatever your experience, our department definitely
Right.
will take the advantage.
Yeah.
And also
First thing I would say, ask the students to watch 21st, even if they're not coming physically, and the game plan for 2023 will be out on that day.
Yes.
So ask them to take part in Robocon,
Yes.
and I think गाड़ी चल पड़ेंगे actually. आपको कुछ नहीं करना पड़ेगा actually. ठीक है ना?
Sir, thank you
Alright.
very much, sir. It was nice talk.
Thank you.
Yes.
Thank you so much, sir. Now I request our HOD sir and additional HOD sir to give memento to our plenary speaker, Professor Dr. S.K. Saha.
Can we have a huge round of applause? Thank you so much, sir. Now I request all the dignitaries and faculties to kindly move for high tea, and we will be having our next session of Dr. Madhu Sudhanpal sir from DRDO shortly. And all the presenters who are present offline are required to be present here itself after the high tea. I request all the student volunteers to kindly assist our dignitaries. Thank you.
Thank you.
Sudhanpal. He did his master's and PhD in human physiology and diploma in ergonomics. Currently, he is scientist and additional director DIPAS DRDO. He is recipient of many prestigious awards like Scientist of the Year Award honored by Ministry of Defense DRDO in 2016, Technology Group Award, Professor Chitralekha Mukherjee Memorial Award, Professor B.B. Sarkar Memorial Orientation Award 2017 by the Physiology Society of India. Now I request Dr. Basant sir to come forward and felicitate our keynote speaker Dr. Madhusudan Pal with a sapling as per Amity traditions.
Also request to our joint HY Professor Abhay Bansal join with us.
Let's now proceed to this session. So I request respected Dr. Madhusudan Pal to enlighten us with his grateful lecture.
Good afternoon, everybody. First of all, my sincere thanks to organizer Amity University and especially from the Professor Basant Singh sir for inviting me and share my thoughts and ideas and research work in front of you. And if you go through the previous today's lecture, I am only odd one. I am not any background of the engineering background. My background life sciences, human physiology and ergonomics. These are a little bit of combination of the amalgamation of subject, how to interface. This is ergonomics is a discipline where it is multidisciplinary in approach, required doctor, engineer, physiologist, toxicologist, any multiple safety engineer for safety aspect and productivity aspect. But my presentation topic is human factor integration and ergonomics, particularly in terms of the product design. In products mean not only product, it anything used by the human. It may be machines, it may be tools or maybe equipment, computer, keyboard, anything we define as a product. And what is the role of the human factors or ergonomics, human engineering, design and development of the any kind of equipment, tools or machine. Then what is the exact definition of the human factors engineering? The science of fitting the task or system to the human for improving the operational efficiency or enhancement of the safety. What is the operational efficiency? But as we are in the defense, operational efficiency means everybody's think only related to defense. But operational efficiency it is applicable for the all in day to day, every time, every moment. And now we are in the conference hall. In the presenting lecture, there is everybody is supposed demand for the any kind of performance. The listener have the defined performance, deliverable speaker have the defined performance. Then how we are enhance the performance and safety. And what is the HFS, human factor specialist, human factors engineers, make a bridge between the designer It may be designer means not only the mechanical engineer, it may be any kind of discipline, design anything, maybe computer engineer, electrical engineer, anything. Everybody follows something design. The designer make a bridge between the designer and operator. Operator means human. Basically, we are anything designed or developed, use for the human only. Then make a bridge between the designer and operator during the development process of any kind of product. When we are design and development any kind of product, at first we have to think design of facilities, any kind of tools and equipments that are compatible with the users or human. This in relation to the human anatomical, physiological, biomechanical and perceptual limitations. How we are optimize different components of the human variabilities or human counterpart during design and development of the process. That is the role of ergonomists or human factors. Ultimate motto is the optimization of the interaction between the human, machine and environment. The good example, now we are doing the organized lecture series. If hall is how it is, there is a required as different component. If it is here open ear DJ or heavy noise, room is dark, light is not available, then the motto is performance is gone down, purpose is be a deficit. Then we have to consider everything how we can to maintain the optimized human interaction machine interface. And this is the best example of the innovation of the bicycle. If you go through the literature, in bicycle developed in the 60, 70 years back, then if the product is final, we have stopped the research, then there is no requirement of further improvement. If you go through the different stages, 75 years it took for the optimize the human comfortable level. How the human will be comfort by using this bicycle, different stage, 75 years spent for the optimize this is the continuous improvement process. As we are in the military, what we do in the military ergonomics and human factor integrations. Our main interest is implement physiological, anthropological and biomechanical principles for design of any kind of the combat platforms, maybe the military equipments and combat gears or the combat load carriage ensembles for optimize the human machine performance, safety, health and well-being of the soldiers. Then engineer this is the main motto, the practice of the human factors engineering or ergonomics. Then what is the main goal? Ergonomics main goal, what is goal? Design a good product. What forward? Increase the user level of satisfaction, decrease the undue worker fatigue, discomfort level, improve the quality of work, reduce the risk of error. In the air traffic controller, the software platform, there is a risk of error is very high. How minimize the error, reduce the risk of injury or illness, reduce the cost, medical cost or any compensation cost. Ultimate motto is the increase the efficiency and productivity as well as health and safety of the workers or individuals. And what is the process of the ergonomics? This is the continuous process and continual improvement process just like ISO. And what is the role of the ergonomics? At first, identify the problem. Then after the identification of the problem, you have to formulate different alternates, solution, what are the alternates? And then apply the alternates, then again evaluate and calculate how it is the beneficial improvement or not. This is the continuous cycle. The whole process is continued for the all basic motto is and during the continuous innovation process, there is not only product, what method also is very, very important. How we do the work, then if the method may be increased, efficiency will be a better tool, less stress and fatigue. Ultimate motto is the increase the productivity, safety, health of the workers or any kind of individual. Then as the role of ergonomics in the human factor into the product, at first we have to know what is definition of the product. The product is an entity that is made for, created through a process and solve the real need for its user. That is called product. And if you go through the whole different product, every product has the unique requirement by the particular specific users. When we are design of development any kind of product, at first we have to very clearly know what is the purpose. who will be the users, why it will be used. So many factors should be considered. Then this is the key element for the design and development of the any product, tools, technique or anything. At first we have to know what will be the target users. It is designed for the all or particular age group, for the able or disabled, young or young generation or the old age, so many factors. What is, we have to know why, where, whom, where and how long. These are the key elements for the design of development of the any kind of product. Then at first we have to identify purpose, requirement. Then you have to identify this product is available product or new development is required. Totally I am going to trying to develop, explain. Suppose you are interested to design, develop a innovative or any product, basically product design in a new product. I am giving that angle only. Suppose if the product is existing in the market or if the product is available in the existing market, then you have to identify what is the problem in the existing product. Then, and limitation of the product. Then develop new product or modification of product. That there is two types. Modification of the existing product or new development of the product. Then based on that, you have to identify the different idea development. After the idea development, you have to preliminary design or prototype. Required is the basic prototype design development. Then my interest is basically your product success rate will be depend how it will tested and evaluated before launching to the market. This is the critical part, testing and evaluation. When you idea development, preliminary prototype developed, immediately if you know your product design has a new strength, immediately protect your IPR. Before further go ahead, protect the IPR. Then when the prototype is developed, testing and evaluation in the lab and as well as field condition as per your type of product. Then take the user feedback. User is satisfied or not. If they is satisfied, then go for the final production. If it is not satisfied, then modification. Again continues in the loop, modification required. And how it is important in the different stage, because during the development of the product, you have to consider so many factors. What will be your end cost of the product? It will be easily maintainable, not useful in the different terrain, not because all these components, comfort, maintenance, durability, all determine your cost. Then all these steps you have to consider during development of any kind of product. And why I am telling the who will be users when you are design developing a product, because human users will vary one to one in so many dimensions. There may be age, sex, different strength, body dimension, anthropometry, cognition, reachability, reaction time, so many factors. During the design and development of any kind of product, we have to consider all the human factor issues and what will be the interest of the purpose of the user. That's why who is very, very important. During product development, at first you have to clearly know who will be use it. Then you come into the where it will be used. Suppose I am giving you the one clothing design and development of the clothing, one kapda hai. मैं बोला एक नया कपड़ा बनाओ, आप कपड़ा बनाना शुरू कर लोगे? Never. At first you have to know who will be use the कपड़ा. कपड़ा कब यूज होगा? समर में, गर्मी में, शादी में, social function में. Then you have to so many dimensions you have to consider based on that, because I am giving the one example in the army. So many different clothing is required, mine sub-zero, desert, normal condition. Then based on that you have to select the material, and that's why where it will be used, very, very important. Then next one is why. क्यों? पर्पस सबका अलग अलग डिफरेंट है. मैं शादी में जाना है, पर्पस अलग है. मुझे क्लासरूम डिजाइन करना अलग है. Why it will be used? If you go through the example, I mean, when we are sitting in the living room, recreation activities, watching television, the purpose is different. Then suppose we are in the military, that is work is diversified. Military means not only they are every time ready for the fighting. They have to do the office work. They have to follow the normal PT exercise. They have to office work, the different activities and leisure time. Then at first we have to know why it will be used for the particular product. Then why, if you know why, then you have to identify when. It may be time pressure condition, it may be real war-like condition, it may be the resting condition. You have to go through the example. Suppose work-like situation, the workload and demand, stress level demand is very high. Then if you go through the marathon runner, sprinter, whole activity is for 9 seconds. The time pressure is very high. Then when it will be used? Suppose somebody is sleeping, rest condition. If you design development any product for the resting condition, then those factors not included in the completed purpose. Then when it will be used, you have to verify very clearly know. Then another factor is important is how long it will be used. When somebody is working in the work schedule industry, they have to same do for the 8 hours, except their food break and other times. Then different time hours, longer duration. Just I am giving one example. Suppose you are interested for the design development of any kind of sports performance equipment or any product related to use in the sports activities. It may be clothing, textile engineer clothing, it may be functional footwear, it may be gloves, it may be anything. One thing is used by the sprinter event for the 9-second activities, and or the cross-country runners. 15 days they have to continuous use. Their clothing or functional footwear not like similar to same, must be different. Then we have to consider how long it will be used. Then suppose you are design and develop a product, how it will judge this is product is good or bad. Then what is the good criteria of your good product? First, number one should be the functionality. Then come into the reliable, how it will be reliable, reliability. Then definitely quality, standardization, maintainability and cost effectiveness, durability and safety, all the key factors of your good product. And effectiveness of the design process is measured by product cost, product quality and time to take in market. मुझे चाहिए product आज, आप दे रहे हो 3 महीने बाद. There is no useless. Then why it is all that thing, product cost and product quality, and all the product cost depend on your formulation of the specification. Specification means user requirement. Suppose you need for the one anything XYZ product, life is use and throw, and 1 year durability. Cost will be same? No, never. Then you have to very beginning, before determine your cost, you have to identify, you have to know what is the life expectancy of the product, durability, safety, standard, all these component you value add your product cost. Then I am just giving one of the example what is the product development cycle, how the product is designed from initial conceptualization to the induction by the users. What is the different step? I am giving the different example of the different products. I am giving the one footwear, because in military or any kind of the functional footwear is very, very complex. But we have thinking footwear means footwear. If we go through the foot biomechanics, there is a once international journal, they have published only the footwear related research article, footwear science. Footwear design development of the big science. Where everybody knows at the age of after 45, we are suffering from the knee pain, arthritis or ankle pain. Why? Why not at the age of 15, 20, 30 or 35? Because in every day when we are walking, we have absorbed more than 700 Newton of force by our the body joints. And very simple equation for calculation, you calculate your weight, multiply by 10, multiply number of steps you have taken in every day. By as per the Newton's third law, that much amount of force transferred to the body, ground to the body, and that amount of force absorbed and taken care by your ligaments, joints from the lower body. When with increase of the age, we are unable to, our body system do not absorb the appropriate amount. That's why we are facing the pain. But when we are design development of the footwear, we have to take care this component. How much it will be dampening the impact force, that much of force. And that is design and identification by your material selection. This is a very, very important role. Then if you, we know, everybody know, US is developed country, and if you know the compensation rate of footwear related injury in the US Army, the huge amount, 110 US billion of dollar every year, the compensation. But in our country, that is concept is not follow for the compensation concept. Then you calculate how much compensation this figure will come in India. Then similarly, during design of the footwear, we have to consider so many factors. Design for the school children, for the military application, for the athletic person, for the orthopedic prosthesis. All the factors we have to consider. Then I am giving that example. When one soldier carry 30 to 40 kg load in addition to his body weight. I am giving example for the 700 ton for the normal day-to-day activity by the normal individual. And they are carry 30 or 40 kg load in addition to body weight, then you calculate how much impact absorbed by the soldiers. And what will be the musculoskeletal health and injury risk of the particular soldiers. And we have studied that when soldiers carry 4.2 kg rifle in his hand, because carrying of rifle, additional 3.5 lakh Newton force, additionally only carrying 4 kg rifle, this much amount force added in his lower extremity. Then what kind of footwear is required for the soldiers, particularly working in the different multiple terrain? It may be not only the plain terrain, it may be sandy, it may be hard, it may be rock, it may be snow. Then how critical, what kind of footwear is required? Then basically they are using DMS shoes, that is directly molded sole. This is the old technology, 65 years old, 1965 technology, still they are using. But now recently DRDO, we are developed a new footwear based on the computerized robotic methods and the different new technology method. At first, as I am told you, we have to identify what is the problem in the existing footwear they are using. That is, identify the problem, then develop the design concept, identify the suitable material, then develop the CAD model and prototype development. After the immediate designing, we have go through the internet search, what is the innovative design features. Based on that, we have protect the IPR. Immediately, we have granted the 2 patents, immediately design patent and product patent is under process. After the protection of IPR, design, develop the prototype, then again tested in the field and lab condition, not only material part. Because what happened in everywhere, everybody is tested only material component. But nobody is bothered, ultimate final product is received or rejected by home users. We have to know what is happening when product is used by the human. Those are the real user. But here, we have tested and evaluated instead of, other than the material, what is the human factor issues. It may be in terms of the ergonomics issues, physiology, biomechanics, kinetics, kinematics. We have all conducted the studies in the lab and field condition. And what is the unique features of our design? If you go through the 2 shoes, DMS, weight is 1.5 kilo per pair. And this is another new shoes, weight is same. But if you consider the functional features, so many advanced features in the new shoes, anti-skid, anti-static, oil surface resistance, and anti-penetration. If you working with during walking, any nail is penetrated through your pain, sole is take care up to the 1500 Newton force, unable to penetrate the keel or any serpent. The anti-penetration property is there. And another important beauty is that in sole, we have introduced, identify the one material, composite polymeric material, as a in-socks. When they are using the in-socks running and any kind of activity, in every stride, up to 20% of the impact force redistributed, dampening. Then you calculate 3.5 lakhs Newton in 20% reduction by using the footwear itself. Then what are the basic and important testing parameters? At first we have to identify when we are standing, our body is sway, move, but it is not visible in the naked eye. Because of the respiratory movement and lungs movement, heart rate movement, every time we are breathing and balance and stability. This is the stabiliogram. This is the black diagram. When you are standing, your body is movement in certain direction. It is not static. When we are using the footwear, If during the wearing in the standing condition, your stabilogram variability is minimum, during the walking or running activity, your effort will be less and minimized. We have find out that new footwear is the stable, increase the balance and stability during the walking and running also. And at the same time, every time we are not falling during running or walking. What is responsible for the slip or fall or trip? Because when we are walking, there are different surface. Coefficient of friction between the surface and your footwear sole, that is the key, playing the big role. And how it is the control? How much your movement in the either anterior posterior movement or mediolateral movement during the walking or any kind of activity. And if it is the anterior posterior movement, you minimize, and then frictional force will be improved. Based on that, we have studies by using the new foot sole material, anterior posterior sway also increase. Then another important issue is how much force and pressure is distributed in the different component region of the foot. If you go through the foot anatomy, 10 region. Heel, forefoot, medial, lateral, different component, how force is distributed. And similarly, we have conducted the study in the desert terrain and find out that new product is the total plantar pressure is minimized in the newly posted. My main interest is design and development of any product. I am giving you the example in the footwear. Suppose you are design a mouse, any visuals, control, display, there is another domain, because ergonomics is a big domain. 3 domain: design ergonomics, cognitive ergonomics, neuroergonomics, environmental ergonomics, so many factors. We have to consider all these things. Then what is the importance of the different force and the pressure? This is the common foot injuries, because due to the amount magnitude of the Newton force and pressure responsible for the foot related injuries. Then this is the gait cycle. During the walking, different phases, how the pressure is changes. And this study we have conducted during carry of 40 kg load in the lab and field condition. It was found that when we are using the composite insole and new footwear, pressure is reduction. And this is all the article published in the different international national journals. Then this is, I am giving you the one example, recently developed footwear. Now another important issues in the army problem is the water bottle. Can you think minus 20 degrees Celsius, how they are able to drink water? And in the in jungle area, northeast, in hill area, how they can drink water? Based on the whole ergonomics principle and approach, we have designed development the water bottle. Presently they are using this one we are using, but this is flexible. Main beauty is that we have identified the material. We know every plastic has one component, bisphenol A, that is toxic and carcinogenic. But we are still using the plastic. In any European country, plastic is banned, totally banned. And bisphenol A is structured is similar to the female hormone estrogen. When we are consuming the bisphenol A by any plastic container or product, body do not know it is the female hormone or bisphenol. That's why so many carcinogenic effect and so many health complex issues coming on. Then this is the beauty of this product. If you put the water inside the bottle and up to put into the minus 20 degree, up to 4 to 5 hours, it will remain liquefied. It not solidified. Then they are able to use in the minus 20 in Siachen area also. And this is the multi-purpose. We have already granted the 2 patents and 1 patent is under process. And the main beauty, one bottle will be the multi-purpose use. You can use as a hot bag, it may be used a water bag, then as a mini pillow when the bunker. And another important features, we have integrated a detachable filter. By using this filter, they are able to drink any source of water, in running water also. And by using this filter, we have tested as per the ISO and ICMR norms, water become safely drinkable form by using this filter. Then at the same time, we have designed load carriage is a major problem. They have to carry different magnitude of load. In addition to bodies, we have recently developed this multi-purpose load carriage ensemble. But he has a very important role in the societal mission also, using by the school-going children. If you go to the curriculum internationally, school children is carry more than 10% of his body weight. This is international standard. But here, 7 kilo, bachcha ka weight 7 kilo hai, carry kare 10 kilo load, up to 30, but nobody is care. What happened during the this process, that's counting all the problems, where design and development of one multi-purpose bag used by the army as well as the school children and college going students. Nowadays, you have observed in the airport, most of the students carry 2 bags. One in the front pack as a laptop bag, and back is for the other accessories. They are using the 2 bags. But using this concept, we have designed a front and combination of front and backpack. And there is a beauty is that if you put the 60% load in the back region and 40% load in the front region, then it will be help you maintain the normal structure of the spinal column. And there is a 2 shape. Upper part is the extruded. In the terms of the ergonomics, we have called the kyphosis. And the lumbar region is put in the lordosis. Every individual has the normal kyphosis and lordosis. It will help maintain your lordosis. Then, this is my last slide. What are the human factor and performance? What is the definition of performance? Performance definition is, goal is predetermined. Everybody or anyone have to perform that particular goal with a limited period of time. That is called performance. Suppose a sprinter, within 10 seconds you have to perform. Then there is performance. And performance depends on workload. And what will be the workload? It may be physical demand, it may be postural demand, it may be environmental demand. Suppose I am giving the good example, the workload, how it will vary. Suppose you are listening the lecture, it very good audible. Suppose your noise level is more than 90 dB. What is happening? My task is same, listening, but I am increasing background noise. Then your workload will be increased. At the same time, create a vibration. Workload, another addition to increase. You are sitting. Instead of sitting, you have to standing. Then additional factors. So many, one by add, value add, just increase your workload. As your workload will be increased, your performance will be decreased. This is the reversible. If that, I am giving the work, it's a work, task, one component always remain in the work itself, task itself for the workload. Then so many factors. Another big factors is the human factors. One load for light for you, but maybe heavy for them. Then individual variation. And what are the variation? Personality. The human personality 3 types. One is the morning type, evening type, and intermediate. And somebody prefer the work in the late night, but somebody prefer in the work in the early morning. This is called personality variability. During why I am giving the example, not only products mean so many products, so many tasks. We have to consider all these factors. Another factor is the human dimension. Suppose you are designing a very simple product is the chair. What are the factors you have to consider? It's a big task. Then shape and size. Based on the human variability, their strength, endurance, so many, another variation, circadian rhythm pattern, environmental complexities. It may be same task performed in the Delhi, Noida, high altitude, desert, jungle. This is the value addition part. The workload will be the vary. These are the level of education, quality of sleep. So many, one source is the human factors. We have to know very, very clearly what are the human factors. You have to consider during the design or development process. Suppose in another domain is neuroergonomics. What is called neuroergonomics? When we are, this is the, give example in the mainly multitasking, the complex in the visual information processing in this workplace. How to design a display. During design a display, you have to consider the contrast, color, background, font, illumination, so many things. Have you noticed in the Google computer, there's so many font type, Time New Roman, Vardhana, these. Why, how it is required actually? Because they are doing continuous research, and which font type and size combination, your perception will be, effort will be minimized. They are doing continuous research. That's why you have to design how much contrast, background, illumination. Then if your background, it is very, very important for the when you are designing for the display. It may be graphics, it may be the visuals, it may be computer screen, text, anything. Then suppose your design is good, but another factor is placement. How it will be placement, the control, inputs, display, viewing distance, angle, all the factors affect your performance and workload. Suppose that this is called the design ergonomics. Then you have to design. And the best example of the design ergonomics is suppose where is the physical workload is very, very minimum, but mental demand is very high. Good example is LCA cockpit. When the pilot, they are doing the flying, all workload depends on the visuals. Suppose you have designed good visuals as per the human factors consideration, but your design is poor. Then design is very, very important. How much suppose you have to using the rudder pedal, throttle, this and that, not reachability. They have to good design also. Then if the design is poor, then the postural load, your mobility, flexibility, reaction time, risk of error will be automatically increased. At the same time, other component will be the environmental factors, noise, vibration, humidity, temperature, terrain. Then all factors, these are all factors you have to consider during design of development of any kind of product. It may be tools, it may be rocket, it may be robotics, anything. It may be even in the school furniture, classroom design, your kitchen design. So everywhere we have to consider all the things. And what are the main variables of the performance variability? Interface design factors, hardware design factors, and design factors, they actually accurate. And another important is you have to decide how much is accuracy is requirement, complexities, productivity, quality, safety. All these things you have to consider. Suppose when the reading, you have noticed in the under sunlight how it is very difficult to find out the text, because there is a poor combination of the contrast, background, illumination level. Then this is the visuals. When we are giving in the under the shades, shadow condition, your effort is very less. And same task, doing the sunlight, the very, very complex task. Then this similar way, we have to consider all these factors for design of any good product. It may be computer scientist or web designer. Where should be the place the control and display? All these factors, if you consider all these factors, then your product will be superior. Otherwise, nowadays, global competition is very high, very, very competitive mind, your product will be not success. Thank you very much. And now, if any question.
Any questions from the audience?
Yes.
Dr. Madhusudan, we had one brainstorming session among all IIT professors, ISC professors, and DRDO headquarter team. Mainly, we want to come with a framework or a policy on the human factors and human reliability. Okay, actually, I steered that activity under DG Sam Madam, Director General Sam Madam. So, yeah. So I think this system engineering, human factor engineering, system safety, all are quite correlated and overlapped also. So I think this human factor, it should go into design of all our DRDO products. Not, it should be not restricted to few products. This should come as a part of the policy document, first thing. The other thing is that when I was going through this human factor engineering part while conducting the brainstorming session, I have gone through the UK MOD policy on the human factors, the standards, human factors standards. Then USA also got human factor standards for the defense systems. So something we need to come with standards for the human factors.
But I am going to share with you. We have already finalized the document for the whole system data, the human factor integration and reliability.
Okay.
And this task is assigned by the director DQRS to me.
Okay.
And the document, final document is ready and approved by the chairman DRDO.
Okay.
It is under the publication from the DCDocs.
Okay.
And very shortly it will be released for the applied for the whole DRDO labs.
Yeah, it's good things. So we had almost 6 months of
maybe become a national document because we don't have the department, have the human factors the safety, reliability concept in the any product in nationwide. We have already done it, sir.
Thank you.
Thank you very much, because we have time short very for you. So, any question? This is last question. Any question from student side? Participant side? Short question.
Yes. So, sir, I saw a recent project in the US where they had incorporated like passive cooling techniques within the clothes as a response to climate change. This was for civilian application. My question is the Indian Armed Forces also considering that sort of stuff?
Actually, what happened now? Everybody is thinking about the heat production,
Right.
but nobody is thinking the heat conservation.
Okay.
You know
Okay.
how much heat is generated by the human every minute? Every minute is 75 watt.
Exactly.
Heat is
Right.
generated.
Exactly.
Everybody is thinking for the heat production, external heat production, but we have to think heat conservation. This is the main beauty.
Okay.
If you are anybody is interested for the textile development, we have to design a good textile, and that is expert is required for the professor join the heat transfer mechanism. If I know how much heat is generated every moment and design a fabric, how much your breathable, your heat loss,
Right.
make a balance between the heat production
Right.
and heat loss.
Okay.
And purpose will be the different. One material for the desert, another material for the extreme sub-zero condition.
Exactly.
This is the, I am thinking and approach so many institutes, but everybody is nowadays, everybody interested in the robotics and simulation, but this is the real thing. If you design one new fabric, and if you know, nowadays, nylon 66, everywhere using, we are able to generate basic raw material, indigenous, we are unable to develop a basic material for the nylon 66, all are imported. If the imported is one, after nylon 60 activity is one. We have to, young generation, think that direction. We are not copying, we have to create the innovation.
Okay, just a little bit. I just want to know, if I want to read a little more about the thermal comfort aspect of this, where would I find...
That's why I am telling now why. At first you have to identify the problem.
Okay.
We talk about the thermal comfort.
Right.
Thermal comfort means in where? Desert?
Right, of course.
An activity or a condition?
Right.
But at first you have to define the question.
Okay, I see.
Thermal comfort for what?
I see.
And for where?
Right.
And why and how?
Okay. Fair enough.
Then at first if you formulate this your problem, everything will be easy to solution.
I see your point. Thank you.
Thank you very much. Thank you.
Delete it. मेरा presentation delete करना है. Delete करो सर. Okay, thank you.
Thank you so much, sir, for your valuable insight. I would now like to call Dr. Basant Singh Sikarwar, HOD ME Mechanical Engineering, and Dr. Manoj Kumar Pandey, Joint HOI, to come on the stage and present the thank you memento to Dr. Madhusudan Pal. Thank you, sir. We are going to begin our technical session now. So the participants who are present offline, please come to the stage and give your presentations so that we can make it ready. All the participants, please come to the podium to give your presentations. I repeat, the participants, please give your presentations on the stage. Paper ID 474, please submit your presentation on the stage.
डेस्कटॉप पे 648 डाल। अच्छा आपका ये सब मेरे पास 1987, MTech REC Jamshedpur in 1993, and PhD from NIT Jamshedpur in 2002. Published over 90 SCI Scopus Journal, over 32 conference paper, guided over 10 PhD student, 54 MTech student, and 34 BTech student group. Total over 34-year experience, in which 19-year experience as a professor in NIT Jamshedpur. Now I request Professor M.K. Pandey and Dr. Basant Singh Sikarwar from Department of Mechanical Engineering to please come on the stage and felicitate Professor M.K. Paswan with a sapling as per MT tradition. Please, Dr. M.K. Paswan. Thank you, sir. Now I invite Professor M.K. Paswan, sir, to please come onto the stage and enlighten us with your thought. So.
Good afternoon, everyone. Respected Chairman, friends, colleagues, and our beloved students. Really, FLAME 2022 is a great conference, seminar of the all young technocrats which are meeting here in 3 days. Really, In this conference, organizer has to take care of all aspects of the mechanical engineering, including robotics, manufacturing, heat transfer, as well as strength of materials, whatever paper you are studying. From the different keynote address, as well as different professors, different applications organizations, just like DRDO, as well as different small scale, as well as big industries. So I hope this technical sessions also gives you more comfortable, more acknowledgeable to the research scholar, especially who is doing the BTech projects in third year, means fifth and sixth semester, as well as final year, seventh and eighth semesters. Really, it should be very helpful to you because you are knowing the different mathematical governing equations as well as its industrial applications, its application in the life. As well as master degree students must be benefited in all the projects as well as PhD. So I wish it is great success. Thank you.
Thank you, sir, for your valuable insight and overall informative talk. I would like to introduce our session coordinator, Dr. Pallav Gupta. He completed his PhD in year 2015 from IIT BHU, India. His area of research include material science, material processing, material matrix composite, and nanocomposite, coating technology, and mechanical behavior. He has published several research papers in reputed journals like Journal of Material Research and Technology, Material Chemistry, and Physics, etc. After these motivating words, let us move to the next phase of the session, and I invite the participant to deliver their ideas through the paper. I will be calling out the paper IDs, so please be ready with your paper. And for the presentation, you have 10 minutes for presenting the presentation and 2 minutes for Q&A. Now first, the paper ID 648.
Good afternoon, session chair sir, and good afternoon, Dr. Savir, Professor Basant, and all the participants. So, I am the co-author for the paper titled A Methodology for Optimal Scaling of Guided and Unguided Rockets in a Military Formation. So, this research outcome is almost close to 8 months of detailed system analysis activity using modeling and simulations being carried out by our team. And this is the real-time military solutions that we have provided to the DG Artillery team, Director General Artillery team. So in our inventory, we have both unguided and guided rockets. Okay. So you can see the recent conflicts between the Russia and Ukraine. There, Ukraine is getting the high mobility rocket artillery systems from the USA. So this is very prominent area saturations weapons. So generally it will have the range of roughly 10 to 200 kilometer, and it is mainly to saturate the area. Suppose area size may be 500 by 500 meter or 1000 by 1000 meter. So it will destroy the complete infantry, complete depot of the army. But the one thing is that disadvantage with this weapon is that we have the less impact point accuracy. Generally accuracy, it will be of the range of 0.5 to 2% of the range. So suppose we got the range of 20 kilometer, so it is likely that we'll get the dispersance of 400 meter. So this is one of the disadvantage. To overcome this
this disadvantage, the recent trend is towards the precision-guided rockets. So precision-guided rockets will have all our avionics package, will have our onboard computers, and complete guidance and control mechanisms. So this will enable that we get the impact accuracy of the range of 10 to 15 meters. So this, due to these emerging technologies, there is dilemma for the military planners, and there is dilemma for the operational operators also. One is having very good impact accuracy of the range of 10 to 20 meter, and one is having impact accuracy in the range of 400 to 500 meter. But there is a difference. There is difference in terms of cost. One is almost 5 times more costlier than unguided rockets. So this paper is mainly to provide the decision aid solutions for all the military planners and operational operators, mainly the artillery team. So this was our objective. So mainly, suppose on the border lines, we have our LOC line of control. So outside line of control, we have different distributions of the area targets. Okay, from 0 to 15 kilometer, different sets of area targets will be there. From 15 to 50 kilometer, different sets of area targets will be there. So mainly we want to give the solutions in terms of optimal ratio of these weapons, guided and unguided rockets. So definitely here one element is there, what is the range of these weapons, what is the accuracy of these weapons, and what is the lethal radius, and the other factor is the cost. So all these are the key decision-making factors. Based on this, we need to provide the solutions. So we have provided these solutions to DG Artillery team. This is just one abstract of that solutions. So for the academic contributions that we are putting up. So for arriving at any problems, we need to identify what measure of effectiveness or measure of performance parameters should be there. So since these weapons, area weapons, suppose any area target is there, it will get some lethal radius. So we have taken coverage. Coverage means in terms of damage coverage. What damage coverage it is going to make the area weapon, this we have taken as a performance, as a measure of effectiveness. So based on this measure of effectiveness parameter, we are going to arrive at the optimal scaling solutions. So since unguided rockets, it will have lots of uncertainty. It is not guided throughout. Just we put the what should be our elevation angle and what we should the azimuth angle. This is just like a projectile. So definitely it is not certain that whatever we are aiming, it is going to hit that one. Okay, it will have some dispersions in the elevation plane, some dispersions in the azimuth plane. So definitely whatever intended target is there, most of the chances are there we are going to miss also, and we are going to hit also. So this is very uncertain. But the big advantage is that we are going to target the area, big target. So definitely uncertain element is there. So definitely probabilistic mathematical models we need to adapt to arrive at this problem. As far as guided weapons is concerned, guided weapons will have pinpoint accuracy. So wherever we want to hit, we can just give the command, we can just feed the target point, and it is going to hit. But its cost still is 5 times more than the unguided. So I think I have said the problem definitions and objectives. So this was very novel solutions. This we have arrived based on our missile system engineering experience. Otherwise, this problem is not very easy to solve. So based on our experience, so we have taken inputs from the rocket designers. Okay, rocket designers has given us 2 inputs. One input is the range table. Range table provides that with the variation, in elevation and azimuth angle, what is range is going to be having. The other input was the error budgeting. Error budgeting means whatever design parameters are there. Now suppose there is mass variations, propellant variations, there is mass variations. Okay, then there will be aerodynamics variations, ballistic coefficient variations. Due to all these variations, what impact point error is going to have. So these 2 inputs we got from the designers, and then we have made the simulation setup. So what we have done, so generally for any missile or any rockets, key trajectory determining parameters are its velocity, its flight path angles in the elevation and azimuth plane, and whatever its positional state vectors are there, x, y, z, vx, vy, vz. All these things determines where we are going to impact. So whatever error budgets was there, like design parameters, are there in terms of elevation, bearing, all these things we have mapped to the key trajectory parameters. So key trajectory parameters, so mainly all the, you can see all has been mapped in terms of flight path angle, velocity, and ballistic coefficient. So these 4 parameters we have mapped it. So since this simulation setup, we require complete operational environment. So we need to operate these weapons in the varying terrain conditions, varying like environmental conditions, wind, meteorological conditions. So all these things we need to simulate. So we have taken one of the COTS software, commercial off the shelf software systems toolkit. So this has provided the platform how to simulate. But we have integrated our missile models, rockets models. So this is one of we have given very simplified form of the drag equations, although these rocket trajectory equations will have quite details. So this we thought that most of the people are aware of rocket trajectory equations, so this, we have given very simplistic representations. So this is one of the trajectory simulations. This we have used for the SMERCH. SMERCH is one of the rockets artillery being provided by Russia to India. We have our own guided and unguided Pinaka rockets. So this is one just representation of the rocket trajectory. So we had made the simulation setup. As we have told that the key trajectory determine shaping parameters were the velocity, flight path angle in elevation, azimuth plane, and the ballistic coefficients. So all these parameters based on its sigma variations, we have set up these parameters in the Monte Carlo simulation setup. And our outputs were the how many numbers of rockets is going to impact to the area target. Is it working? So like how many numbers of rockets is going to impact into the specified area target. We have 3 area targets. One was 250-meter radius, one was 500-meter radius, one was the 1,000-meter radius. So how many rockets is going to impact? This is one of the output parameters. Then using its lethal radius, how much percentage coverage is there to the area target. Then military planners, they can have 30% coverage as its performance measure of effectiveness parameters, or 40% or 50%. I will not disclose on all these things. So it is up to the operational planner how they visualize what is their damage criteria. So this simulation setup was there. So this we have almost taken almost 10,000 runs. So this is just simplistic representation. We have almost taken 10,000 simulations run, Monte Carlo simulation runs to arrive at these problems. So for varying, suppose minimum range to maximum range, each 5-kilometer interval, how many rockets will be required, with then how many rockets will be required for the 40% coverage, all these things we have determined. After computing these things, so this is the computation steps. So these were rocket parts, but there will be target variations part also. From the boundary lines, generally when in the operational, adversary will have deployed their military formations near to the boundary. Little farther there will be little, less deployment will be there. So what is the variation in the target distributions? This is one of the factors. Then what is the range we are going to get? What is the accuracy we are going to get? And what is our lethal radius? The other factors are there. Then cost. We have assumed that unguided rockets, guided rockets has 5 times more cost than unguided. This is true also. This is actual figure we are quoting. So based on these things, we have evolved the methodology, we have computed, and we have arrived at the solution of what should be the ratio of the free flight rockets and guided rockets. The actual number we are not going to disclose. So this is just, this paper contains, restricts to the methodology how we are going to adopt. Okay, so this was the methodology we have evolved. This concept was implemented using the systems toolkit. And this is quite useful. This is direct from the Director General Artillery, we got this problem. So we have given these solutions. These solutions can be used for the military budget planning also. Suppose the artillery team, what numbers of weapons they want to have, they can use this one. So overall, I want to say that this system analysis, system engineering, this is interdisciplinary domain. here, like this is not just like one mechanical engineering or electronics engineering. So to work in this domain, one should have system thinking aspects and system engineering experts. So if one works on various domains, so this expertise develops on. And then modeling and simulation is one of the very useful tools. So whatever real data we can't simulate, so this gives us platform to replicate the actual performance. So, and this thing we can add to our military planners. This can be used for our design and development decisions also, performance decisions also. So this got very wide applications, and this is useful for most of the students. So sir, these are our references. Although direct references we do not have, because this was quite novel approach, but the references related to the rocket trajectory equations, rocket trajectory simulations, so all these references are got. So this was presentation from our side. Any questions?
Thank you, I.D. Kumar. Really very deep knowledge about the guided and non-guided rockets. So you have touched about the different trajectory parameters, its variation, drag force, computation, Monte Carlo simulation setups, target range. So different terminology you have used as well as stimulated in your presentation. So excellent presentation. Any question from the audience?
This rocket missiles, looks a little tough, but it's not very tough. Like whatever any physical systems are we got now, many rockets got, missiles got. So this is a physical model. So what is there, like these physical models, we can represent by mathematical models. Mathematical models is nothing but its differential equation representations. So whatever models we have, so any vehicles we got, any missiles, rockets, or radar, everything gets represented by the mathematical models. So you need to just solve these mathematical models using some of the numerical integrations methods. Then you can derive what actually it is going to perform in the operations scenario. So looks tricky, but it's not that tricky. So this is just thing.
Okay, thank you, I.D. Kumar.
Thank you, sir.
Thank you, Nandal sir. It was very insightful paper presentation. Now I would call paper ID 548.
Good afternoon, everyone. I am Bobby Singh from Galgutias College of Engineering and Technology. I am present here to present my paper on behalf of my group. The topic of my paper is a review on application of heat pipe to improve vapor compression refrigeration system. First, I talk about heat pipe. A heat pipe is a two-phase heat transfer device having high thermal conductivity. It is also called superconductors, and there are three components, that is container, working fluid, and wick structure. Here you can see the heat pipe. There are three sections, that is evaporator section, adiabatic section, and condenser section. The evaporator section, when a heat input given to the evaporator section, the working fluid present in the wick structure gets evaporated and start moving towards the condensation section, where the temperature of condensation section is lower than the evaporator section, where it can condense and the latent heat can transfer to the environment and the condensed liquid back to the evaporator section through capillary action. There are different types of heat pipes which generally used in electronic devices or refrigeration systems and space, that are thermosiphon heat pipe, loop heat pipe, and oscillating heat pipe. There are differences, features, merit, demerits, and application of all the heat pipes. Standard heat pipes having feature of gravity independent. We can we can put it in any device having more heat in any orientation. It is independent of gravity. As well as thermosiphon is a gravity dependent. It only works on vertical orientation. Here is a vapor compression refrigeration cycle which consists of four parts, that is compressor section, condenser, expansion valve and evaporator. At compressor section, the refrigerant can compress and it converts to a liquid form and then transfer to the condenser section where it can reject the heat and converts to a vapor, and then move to the expansion valve where the high pressure refrigerant get converted to a low pressure vapor, and then it sends to the evaporator section where it consumes the heat from the environment and converts into the vapor section. Here are some recent research in which the heat pipes I discussed before are used to improve the COP of refrigeration systems. Like in first paper, they used a heat pipe heat exchanger in which they are installed at the condenser section of the window AC, which improves the 10% of COP. And in rest of the papers, they also used different heat pipes at different sections of the window AC or split AC to improve the performances. Here are more recent researches in which to improve the performance of heat pipes by using different working fluids like water, ethanol, methanol, and in different sections, heat exchangers are also implemented on different applications to improve their heat transfer capacity. Now come to the conclusion part. As to improve the heat performance of heat pipe, many researchers had done researches like using different working fluids to improve the heat capacity, and water is one of the commonly used working fluid because of its high latent of heat carrying capacity. And nowadays nano fluids are also used to improve the heat transfer capacity of heat pipes. And the COP improvement of vapor compression refrigeration system, there are, as I discussed before, that many researchers implement a heat pipe at different section of refrigeration cycles to improve the COPs. It also improves the economic performance because when we implement a heat pipe, heat transfer as many as possible, which reduce the compressor work, which also indicates to reduce the energy consumption. That's all about myself. Thank you.
Thank you, Atul. Good work on the heat pipe. You have done your performance, condensation, thermodynamics, refrigeration cycle work. Finally, you have good work in the economics performance. So, very excellent work. If any question from our audience?
Any question from audience?
Recently, I found that when we read many research papers, most of the researchers have done implement heat pipes at different sections, but at condenser section there is limited research. And my final project is also based on talking about this improvement of application, improvement of VCRS using heat pipe. What I should do is we take a standard heat pipes, 4 heat pipes, and put it in a holder and consist of fins at different sections, and I put into the condenser section, which reduces the temperature of the refrigerant which comes from the condenser part. And after the capillary tube, when it transfers to the capillary tube, it reduces the temperature, which increases the cooling capacity of the. It's a significant.
Just a small request to all the participants who are delivering their paper over here that we are running short of time, so I request you to please deliver your paper in just 7 minutes with 2 minutes of question answer. Thank you so much.
Thank you. Now we will call paper ID 474. Thank you.
What is your name?
Anirudh.
Anirudh.
G-A-N-I-R-U-D-D-H.
Hello everyone, my name is Anirudh Tiwari. I'm from Jamia Millia Islamia, New Delhi. I'm currently in my final year, mechanical engineering. I'm here to present a research paper based on future scopes and development on nano refrigerants in the refrigeration system. So, in the introductory part, we all know that we have to face much hazardous air infected with harmful gases such as carbon dioxide, nitrogen dioxide, by using these conventional refrigerants in our day-to-day life while heating and ventilation equipment. The essential use of refrigerant is the transfer of heat from a lower body temperature to a higher one because it has very low boiling temperature than any normal liquid. This process is also known as refrigeration process. Many studies have shown that nanofluids can increase the heat transfer capacity in a way more than a normal one. It has better thermal conductivity than our normal conventional refrigerants. Thus, stable nanofluids can be introduced as a mixture of nanoparticles in the future. It can reduce our energy consumption until 20 or 30% in time. It will require less compression work, which will increase the coefficient of performance with an increased heat transfer rate, resulting in an increased cooling capacity of the equipment. Now coming up to the various types of refrigerants that we are using, that we have already used, such as conventional refrigerants, which is chlorofluorocarbon based. Chlorofluorocarbon refrigerant has a chemical formula of CCl2F2, that is dichloro-difluoromethane. This refrigerant has very harmful impacts on our surrounding due to its chlorine, because it is the major element of ozone depletion. It has been banned from the late 90s. However, research on dispersing nanoparticles in this refrigerant is being done under some projects. Examples of those under research projects are R11, R113, and R12. Experimental results have also demonstrated that the situation of carbon nanotubes increases the nuclear pool boiling heat transfer coefficient of R113 oil mixture up to 1.61 times, that is more than 61%. Under the experimental conditions. Coming on to the another refrigerant, that is hydrochlorofluorocarbon based. Since chlorofluorocarbon refrigerants had many drawbacks, researchers introduced hydrochlorofluorocarbon. The refrigerant has a lesser amount of chlorine, resulting in less ozone depletion potential. Its availability is much better than the earlier ones. Example of HCFCs are R141B, R123, and R22. If we disperse aluminum oxide with aluminum, copper, or copper oxide in R141B refrigerant, having structural formula as chloro-difluoroethane, the average heat transfer coefficient of these nano refrigerants was enhanced by 1.3 to 1.20 times, that is till 20 to 30%. However, nano refrigerants' maximum heat transfer coefficient increased by 1.17 to 1.25 times. By putting extra SDBS surfactant, that is surface surfactant, in Al2O3 mixed R141B refrigerants, the increment of the boiling heat transfer properties enhanced from 0.01% to 0.1%, but the volume concentration has lowered by 0.001%. Coming to another refrigerants such as hydrofluorocarbon, that is HFC based, With the mandate of eradicating chlorine from the previous refrigerant, that was HCFC as well as CFC, this refrigerant doesn't contain any chlorine particles. However, it does harm global warming because it contains a specific amount of carbon dioxide. Examples of these refrigerants are R123, R407C, and R134A. The experimental analysis result shows that R134A dispersed in Al2O3 PAG nano refrigerants usually operated and did not deteriorate the refrigeration system. Compared to the pure R134A, the 0.2% volume-wise concentration of R134A nano refrigerant showed better refrigeration system performance with 10.3% less energy, making it energy efficient, which is the requirement of current scenarios. Coming to the limitations of the nano refrigerant-based refrigerants, dispersion of nanoparticles in refrigerants results in nano refrigerant while the compound is slightly unstable for the prolonged time due to different thermal physical conditions. In contrast, an average operator desires maximum uses of refrigerant-based equipment. Therefore, an extended duration usage of refrigerant is needed in day-to-day life. It is essential to understand the behavior of nanofluids and the physical mechanism of heat transfer because phase change in the refrigeration cycle happens continuously over the period of time between the evaporator and the condenser just because of compressor. We already know that the refrigerants in the original form are causing undesirable environmental effects such as ozone depletion and other many reasons. Thus, if we increase the use of nano refrigerants, it may further enhance the unwanted environmental and health outcomes of the refrigeration system. Future scopes. Uses of various surfactants such as sodium didocyclobenzene, sulfonate, and many more can be used while the dispersion of nanoparticles in the fluid to check the abrupt behavior changes in the thermophysical properties. New techniques such as stimulations can be implemented to synthesize a good quality of nanoparticles and for the efficient and effective dispersion of nanoparticles into the base refrigerants. Coming to the conclusion, most researchers have stated that nanoparticles significantly enhance the heat transfer rate by dispersion of the actual size of nanoparticles in the base refrigerants. The energy load of the equipment can be reduced, meaning that the coefficient of performance is increased and the work done by the compressor to transfer the heat in the vapor compression cycle is decreased. Most researchers used metal oxide, that is Al2O3, TiO2, copper oxide, and carbon allotropes such as HCFC, HFC, etc. in the nanoparticles division. Degradational and migrational properties of nanoparticles have a significant role in enhancing the heat transfer coefficients of nanorefrigerants. Thank you. We are open for questions, if any.
Good, Anuruddh. You have indulging nanoparticles in refrigerant in the refrigeration systems. Good work. So open for audience. Any question?
Any question from audience?
What is your contribution in this paper?
It is a review paper, what is already mentioned. So I have reviewed lots of paper, more or less 9 to 10, and then I've concluded the research that can be done in the future, as well as the limitations that are in this particular field.
Thank you.
Thank you.
Now, paper ID 541. 541.
So good afternoon all. We are here to present our study, effect of nose cone geometry on the fluid flow over a rotating cylinder body. Myself is Naga Harish, and with me is Nitesh and Prahlad. all three of us will be presenting our study. We are fourth year B mechanical students from Nitya Meenakshi Institute of Technology, Bangalore. So this is a slight outline of the presentation for today. So slender bodies, basically slender bodies are the bodies which have diameter which is very small when compared to its length of the body. Examples of these bodies can be from bullets, rockets, aircraft fuselage, and ship as well. So basically these bodies can have both symmetrical and asymmetrical cross-sectional areas. This shape is basically used for the reduction of drag and disturbance and the fuel consumptions, usually used in sectors like aeronautical, aerospace, marine, and the defense domains. These bodies are mainly used in places where the body has to move against a fluid. Our basic inspiration for this work was from the recent developments in the subsonic cruise missiles like Nirbhay and Nag. All these missiles are in subsonic regime. So that was where we started our study. So our study was a preliminary study on how the nose cone affects in the subsonic regime. It's a numerical study, and now I'll be leaving the presentation over to Prahlad.
The main objective, the main takeaway from the literature review was to determine what kind of turbulence modeling we were supposed to use for the numerical analysis. From the literature review, we found out that the major parameters for the study done from the literature, that we found that the roll damping and the Magnus force analysis was done. And then we found out that the rotation is incorporated into the body only when it is for a particular specific product. And when studies involving high Mach numbers is done, we found that the nose cone or the whole body is rotating. The major literature gap that we found was that the rotation of the body was not done for the subsonic regime. From the literature review, we formulated our objectives of the study as to design the slender bodies of different nose cone geometries, to analyze the variation of the flow properties under the rotating conditions for the 0-degree angle of attack, and comparison of these obtained results for different nose cone geometries as our preliminary study. Now I call upon Nitesh to continue the presentation. Thank you.
Yeah, coming to the methodology, we have considered 3 models of different nose cone geometries. The first model is conical tip 1, and the second model is hemispherical tip 1, and the third one is a ogive model which has a step at the intersection. So we have generated the model using the Fusion 360 software. So we have used these expressions to calculate the nose cone parameters for all the 3 models. Yeah. Coming to the meshing part, we have considered 2 domains. The outer domain is coarsely meshed and the inner domain is finely meshed. And also 10 inflation layers has been added to get better results near the wall. So we have also considered mesh independent study. So we have considered a coarse, medium and fine mesh. In coarse configuration, we got less accurate results, but also the computational time was very less for this configuration. And in medium mesh configuration, the results which we got had better accuracy, and the computation time for this configuration was also a moderate one. And the fine mesh configuration gave better results, but the computational time was very high. So we have considered medium mesh configuration for our study. So coming to the boundary conditions, the inlet velocity for the body was given as 274.4 meter per second, or it's 0.8 Mach, and the body was rotated above the longitudinal axis with 900 RPM. So, and the outlet faces have been set to outflow condition. So coming to the results and discussions, so these are the velocity counters. As you can see, there is no stagnation point in the first model. This is due to the sharp geometry. And in the model 2 and 3, we can see a stagnation point at the tip because of the nose cone geometry. And also, we can see the wake region in all the 3 models. So coming to the wall shear stress counter, in the model 2, we can observe least wall shear stress when compared to other 2 models. And also in model 3, we can observe high wall shear stress over the nose region when compared to the other 2 models. So we have plotted the graph of wall shear stress versus the distance along the slender body. So coming to the pressure contours, we can see that high pressure region near the nose region for all the 3 models, and we can see low pressure regions at the intersection point for all the 3 models, and we can see the model 1 has least low pressure region, and model 3 has greater area for low pressure region by seeing the contours. So we have plotted the graph for the same slide. So coming to the wall temperature, we can observe that model 1 has high temperature at the tip. This is because of the less surface area where the heat dissipation is very less. And as we go along the slender body, we can see that model 3 has higher wall temperature when compared to the other 2 models. So coming to the Q criterion. So Q criterion is the area where vorticity magnitude is very much higher when compared to the rate of shear strain rate. So we can see that in the model 1, very less amount of Q criterion can be observed when compared to the other 2 models. And in the model 3, we can observe least Q criterion right after the step region. And also the Q criterion increases in a higher manner as the flow passes over the slender body. So coming to the conclusion, so the velocity distribution indicates that the first model, that is a conical model, has the least resistance to the flow when compared to the other 2 models. And in the case of Ojai model, due to the Ojai shaped geometry of the nose, it offers greater resistance when compared to other 2 models. By the temperature distribution curve, it is observed that the temperature at the tip of first model is very much high when compared to the other 2 models. And along the body, we can see the third model, that is Ojai geometry model, has very much high wall temperature when compared to other 2 models. So coming to the pressure contours, we can see like all the 3 models had high pressure region at the nose area and low pressure region at the intersection region. So coming to the wall shear stress, we can see that model 2 has the least wall shear stress when compared to the other 2 models. But model 1 has a high wall shear stress at the tip region. That is because of the sharp geometry. So these are some of our reference. Thank you.
Naga Harish and friends. Which software you have used? Fluent?
So for modeling, we have used Fusion.
Fluent.
Yeah, and for competition, we have used Fluent.
Good work. Open for audience.
Any question from audience?
Your presentation is very well organized.
Thank you.
I have a very small question. How you have decided the dimensions of your setup?
Sorry, sir?
How you have decided the dimensions?
Model dimensions. Right. So what we did was we took the length of the body to be 100 mm here.
How you had decided 100 mm?
With the formulas which were there. So for that we have taken the nose parameters. We have inputted. We have kept the length of the body to be constant as 100. But later on we used the formulas to get the nose part of the slender body. The cone angles and all of that.
Okay, thank you.
Thank you, Nitesh. Now paper ID 528.
am sorry to interrupt you in between. I once again request to all the presenters to please wind up their papers in 7 minutes, and 2 minutes will be there for question answer, because we are running a lot of short of time. So please try to wind up within the time frame. Thank you.
Good afternoon, everyone, audience and panel. I am here to express my presentation on computational analysis of transfer of heat in micro-sized channels using different boundary conditions in laminar flow. First, we will go through presentation outline in the sequence: abstract, introduction, applications, results and discussions. After that, conclusion. The main abstract was that we are using nowadays various electronic devices such as laptops, even though our phones gets up heated. And it is not only limited up to these uses. There are various applications where we have analyzed that there needs to be minimized the heating issues in these devices. For that, there is a device known as micro channel having hydraulic diameter less than 1 mm, and we are working on it. So first of all, we will know that what is micro channel. Micro channel in macro technology refers to a device which has hydraulic diameter less than 1 mm, and it is used as a heat exchanger. And there are various classifications like conventional channels, mini channels, micro channels, nano channels, and we can see in the graph that based on the hydraulic dimensions, these are classified. Advantages. What are the advantages of micro channels? There is improved heat transfer coefficient, as the size of the channel is very small, and its smaller size allows increase in mobility and usage. There is one more advantage, that due to its lower weight, it reduces the structural and support requirement. What are the disadvantages? Then there, as we have discussed, that improved heat coefficient, it increases the high pressure loss due to less hydraulic diameter, and it prevents uniform flow of cooling material along the channel. Applications. These are broadly used in various MES devices like micro channels, microcontrollers, aircraft, manufacturing, and in the future it will be used more widely. There were various mathematical models used along with Nusselt number and Reynolds number, as we know that we all are familiar with it. Results and discussion. The various simulations have been performed to determine the Nusselt number for different entrance condition and 5-wall heat flux boundary condition at different aspect ratios ranging from 0.1 to 1, and the fully developed condition has been taken for simulations. As we can see in the graph that temperature variation at entrance of micro channels. At the entry, with respect to its temperature and with variation, we can that there is decrease in temperature, and after that it remains slight, there is slight changes and then increases. The same graph follows with the height. Now effects of entrance on micro channel on Nusselt number. The entry type has actually no substantial effect on Nusselt number in the inlet zone. Conclusion. For all the situations analyzed, the conclusion suggests that entrance type has no effect on Nusselt number. In the present work, numerical simulations have been run with uniform wall heat from various boundary conditions such as 1 to 4 wall boundary conditions. And these are the references which I have already used. Thank you.
Good. Good work. On the micro channels, your effect of Nusselt number, Reynolds numbers, all are you have shown. Good man. Open for discussion from audience.
Any question from audience? Thank you. Paper ID 682. 682.
presenting a review paper on safety features in two-wheelers. So the wheel has been the turning point. The invention of wheel has been the turning point for the advancement of technology throughout the years. We can see how it has grown from a bullock cart to a car. Why I'm giving special concern to the safety features in two-wheelers is because it has been one of the most widely used vehicles in India, and the following census shows the same. About 32.7 million vehicles were enlisted in, let's talk about Uttar Pradesh because we're residing in the state. In the year 2019, out of that, about 26 million are two-wheelers. So we can say about 92% of what is considered as registered vehicles consists of two-wheelers. And when we see the Delhi report for 2019, we can see how much we require the safety features. The fatality rate and the injured rates here are confer to the two accidents occurring in the two-wheelers only. Now, one thing that we all need to take in consideration while we design any safety features for two-wheelers are the constrictions or the restrictions that we have already, because majority of the two-wheelers are designed in such a way where the additional changes are not possible. Some of the feasibility conditions we need to keep in mind while designing the same are the design that we are incorporating needs to be compact, and it should be fitted into spaces, into a very small space. Minimum changes in existing design so that they are incorporated in a wide variety of the vehicles. We need to take in consideration the weight, because two-wheelers are vehicles which are mostly handled by humans, and the weight of the vehicle needs to be conferred with the ability of a average human being. Deployment condition, specification accuracy means that the deployment of the airbags should only occur during accidents and not, because bikes also tend to go on very rough terrains. Advanced fall predictive algorithm means there needs to be there can be no question of the failure of this system, because safety features is already a backhand support for a two-wheeler. And the materials actually always have to be reliable and equipment in case of safety features. Types of safety features system, they're active and passive. Active safety system are those which are active and in existence throughout the journey of the vehicle, whereas passive safety system only comes into play during case of accidents, collisions, or any act which is off course of the vehicle. Some of the passive safety system that I've included in the system, which can be incorporated throughout the vehicles, are airbags, which are attached to the vehicles, helmets, and wearable airbags. Let's talk about airbags attached to the vehicle. We already have a vehicle known as Honda Goldwing 1500, who released a vehicle with an airbag, but there has been a lot of disadvantage, which would be discussing later. And this bike has not been a success majorly because of its bulky nature. And there's also been current research going on in Yamaha for the airbags in scooty, and the current trials are going on, and we may see a scooty with airbag in a year or two. There's one technology that is going under research by a group of students in Pune, where they introduced airbags which open from the sides instead of the chest region. So these are the different components of the sensors. As due to shortage of time, I'm not be covering them in detail. The working depends upon, there are two sensors, G sensors and the angle sensor. The G sensor detects the movement of the vehicle through the three axes, X, Y, and Z. And the decision, according to the decision that is made due to the pre-set values, a pyrotechnic device is initiated. What is a pyrotechnic device? A pyrotechnic device is one which has a property of an electric match, or it gives energy of its own, and a spontaneous reaction goes on, which gives a temperature of about 3000 to 4000 degrees Celsius, which is required for the reactions that are shown here. So this temperature has to be given so that the nitrogen gas is released into the airbag, and the airbag actually opens up. Then we have helmets. Helmets have been in the picture from the starting of two-wheelers, and we can see Alta headgear. We have seen them through the Shark Tank India company. they have got their entry into the market through the Shark Tank India. And this is an advanced helmet which has very different features of about touch enabled and about whenever an accident occurs, an SOS emergency situation system. And a group of students have taken this research a little forward and added a lot of more of these technologies, such as our alcohol sensor, a speed detector, a helmet if a helmet is worn, and a lot of these. So here I have shown it a very basic circuit of how they have connected everything. So RF communication circuit is shown here. It connects the different units, the helmet and the control unit, wirelessly. Then we have the reed magnetic switch. The reed magnetic switch, they collect the value for the speed of the vehicle. Then we have the alcohol sensor, which is the common. The Arduino Uno is a board which has the 16 inputs and output switches, which connects the whole system all together. And we have the FR sensor. FR sensor is a force resisting sensor. It works on the principle that the resistance of the device is inversely proportional to the force implied on the sensor. So it infers to the property if the helmet is actually worn or not. And this is a decision-making process, is how the helmet responds to the different conditions while traveling. Then we have wearable airbags. Wearable airbags, which can be worn by human beings and have been one of the are not very full researched area of safety features. Hoving helmet with airbag. They have already made a collar that inflates during accidents, and whereas there has been jackets that have also been here. So a mechanical inflator system is used here. Mechanical inflator system here basically has a ball which is attached through a magnet, ball which is inside a tube and is on one side of the tube, which is attached to a magnet. And in case of force, due to the impact, the ball moves and completes a circuit, enabling the system to work. This is how it works in general. Now, conclusion here is the different advantages and disadvantages of different systems. In Honda Goldwing, we have the airbags where there is a risk of rupture because the initiator that is used here has a very high potential of getting ruptured and cracking through the airbag system. Then we have it only selective performance opportunity. It only have very low configurations where they would actually work and would impact the fall algorithm. And compatibility, it is not compatible with all vehicles. It only works in Honda Goldwing because of the structure of the seat that is made, which restricts the movement of the vehicle. Design under research, it's suitable for low CC vehicles too, because there has been research going on it. It prevents skidding, it's compatible, but the positioning of the system is a little complicated because it might interfere with the foot region of the driver. Intelligent helmets are, they might make the helmet bulky, so that would be not suitable for use. And we have range means the range of the RF communication circuit. So if the helmet is not in the range of the vehicle, then the system would not be initiated at all, and it would counter the purpose. Then we have the wearable airbags. Wearable airbags is less. The response time is very less because it has a mechanical inflator in respect to the electrical or the computerized sensor. Then the jacket might become bulkier. Then there's a very high condition of airbag deployment failure because the reason why the airbag is getting deployed is only when the driver is not in contact with the vehicle. There's a string which connects the airbag to the vehicle, and if that is stretched for any other reason, the airbag might get deployed. And the quality of the cloth material under which the inflator is introduced has to be the same as the airbag material, which is not a very variable situation. Thank you.
Really, safety features is everywhere required in our two-wheelers, four-wheelers, everywhere. Good work. So, any question from audience?
Any questions from audience? Thank you, Ria. It was very insightful presentation. Now we will move with ID number 624.
ID number 624.
Good afternoon, everyone. I am to present the papers. Title is Dynamic Performance Enhancement of Fuel Cell using PID Controller. And the introduction is the fuel cell is a device that directly converts fuel energy into a DC through an electrochemical reactions rather than a combustion reaction to heat. A fuel cell includes an electrolyte sandwich among thin electrodes. And there is a need for mathematical model to analyze the behavior of PMC systems. This PMFC model utilizes fourth order nonlinear equations. This requires time consuming and complex calculations in order to maintain the dynamic behavior. Its air feed system is separated. LPV based HNT controller is designed to improve the stability, robustness and performance by authors. The axis is the performance and robustness of the proposed controller. Simulations are preferred with the variance in inputs. The time response simulation ensures the robustness of proposed controller. The fuel cell mathematical model varies with changes in operating conditions. Thus, there is a need for a suitable controller to design and improve dynamic responses under certain environment. One of the promising renewable energy power source is proton exchange membrane fuel cell. The supplied pressure is maintained by cathode side of PMFC. The problem is with the variation is operating temperature and pressures. Its output voltage and current get adversely affected. Thus, there is a need for suitable robust controller design to enhance its dynamic performance. The fuel cell uses the chemical energy of hydrogen or other fuels to cleanly and efficiently produce electricity. Thus, there is a need for suitable robust control design to enhance its dynamic performance. In this work, using the time domain model of the PMFC approximation of its first order, including time delay variations, time delay version is required. Thus, uncertainty modeling of the fuel cell is done. The controller performance is validated through simulation based on real-time fuel cell enumerated system. The simulation result shows the controller is robust and has a good transient performance under parametric uncertainties. And the methodology used in this work is PAM, proton exchange membrane, PID controller, linear parameter, LPV, and solid oxide gas fuel cells, and MATLAB simulations. And the result and discussion section. Before the controller development, plant modeled about some predefined operating points. The main objective in designing the PID controller is to adjust the reactions of controller to set point changes and unmeasured disturbances such that variability of controller error is minimized. PID controller are implemented mainly for the aim of holding measured process value at a set point. And the PID tuner command are used to find the PID controller functions to achieve desired performance and meet design requirement. This is the step response of PMFC model with PID controller. And this is the Simulink model. And the conclusion is that the linearized model for the nonlinear fuel cell system is derived and a linear PID controller has been applied to it. It is observed from the simulation result that the output response is almost tracking the reference by providing a minimum objective functions value. Uncertainty analysis of the PMFC is performed to show the variation of the plant. The plant transfer varies depending on operating conditions. The controller design is implemented in MATLAB. The simulation result indicate that the inverse response compensator has excellent control capabilities in comparison with the PID controller on modeled PMFSC under a certain environment. Thank you.
So, in fuel cell, you have used the MATLAB simulation. Good. So everywhere MATLAB is the instruments you can use. So good work. Any question from audience?
Thank you.
Thank you.
Now moving ahead, paper ID 578. Good afternoon all. My name is Kunal Gaur. I came from Manav Krishna University, Faridabad. So my topic is productivity analysis of pyramid solar cell using phase change material and hybrid nanofluid. So here's the content. First we will cover introduction, then literature review, problem formulation, methodology, results and discussion, conclusion, and last is the reference. So in introduction, the availability of pure drinking water is sufficient quantity and acceptable quality is a fundamental requirement for all living species in the modern world. Here is 1.386 billion kilometer cube of water is present on Earth. That is 71% of the land covered on Earth. Out of which 96.5% is salt water. All species on Earth can access groundwater, river, lakes and streams and only 0.7% of the remaining 3.5%. The remaining water is frozen and is contained in freshwater lakes, polar ice caps and glaciers. So here is as a result, solar desalination is one of the innovative methods that uses sun's free energy to remove salt and other impurities from saline water and generate pure drinkable water. So the device utilized for this conversion is the solar still, which evaporates and condenses saline water and can be created in variety of shapes and sizes. So here we have used is the pyramid shaped solar still because it has a greater surface area of contact of the solar radiations. So here is the literature review. Next is the problem formulation. The productivity of the solar cell is the main issue here. With a typical solar cell, the productivity of fresh water efficiently throughout the day is relatively low. Therefore, a bigger output of pure water from the improvised solar cell is needed. It has been observed that the limited work is done on the solar cell by combining the hybrid nanofluid and PCM as an active agent for research purposes. So methodology is the measurement of the ambient temperatures and intensity, glass temperature in a basin water temperature and overall yield of the clean water were made between the hours of 8 to 18 according to the IST with a 1 hour break. So the process operates between the square pyramid glass table box solar cell and the rectangular flat glass top box solar cell receives an solar radiation. This causes pure water to evaporate from saline water, which then causes pure water to condense in droplet underneath the glass cover, creating a greenhouse effect. Then it is collected via the trough through the pipe into the gauging container. So here is the 3D diagram and the model that we have created in our campus. These are the study for this is the study A, in which only the nanofluid agent is taken into consideration. Here we have taken the ambient temperature, solar radiation intensity, and in the second graph the overall production of the pure water with respect to time ambient temperature is taken. Here is the study B. Here the PCM along with the nanofluid is taken into consideration. Productivity and enhancement comparison done in between both the study A and B. The study B generates 3.89 liters per day of pure water when compared to the 3.61 liters per day of the pure water, which is only the nanofluid agent is taken into consideration. So the conclusion is the mixture of Al2O3 and CuO water nanofluid along with the paraffin wax creates the more pure water when compared to the only nanofluid agent. Here are the references. Thank you.
So you have used solar steel, experimental work.
Yes.
Good work and purifications of systems help. Any question from audience?
How did you optimize the parameters?
Sir, it depends on many parameters that are in ambient temperature, solar radiation intensity, and water depth. So it depends on many aspects. We have reduced the water depth up to 50 mm. That increase the evaporation rate. So that's how it enhances the evaporation. Thank you.
Thank you, Kunal. Now we come to the last presentation of the session, paper ID 251. Paper ID 251.
I think absent.
Last call, paper ID 251. Okay. So now we conclude this session. Now I would like to request Dr. Basant Singh Sikwar, HOD Mechanical Engineering Department, to come on the stage and present the thank you memento and gift to our session chair, Dr. M.K. Das. M.K. Paswan, sorry. Thank you, sir. Thank you all the participants and faculty coordinator, Dr. Pallav Gupta, sir. Thank you.
हाँ हाँ क्या सर वो मैं लिंक भेज दिए सब थैंक यू सो मच ओह हाँ मैं वो मेरे साथ मैं अभी नंबर भेज करी
Okay, it's a short announcement. Next session will start in 5 minutes.
ये बदलवा दीजिए हेलो हेलो मैं सारे इसके हटा कर हेलो ये अंदर बसंत सर बैठेंगे ठीक है पांडे सर बैठेंगे बसंत सर बैठेंगे लगे रहते हो वो सब देखिए अभी इंडस्ट्री से इंडस्ट्री देखिए पांडे सर हटा दो सर हटा दो बोला पाल का मेरे हेलो थैंक यू सर
machining, yeah. We are more used to the plastic, the hardness. And the share.
Technology wise. So is second step and the sun.
But then, you know, most of us know it's a second step.
Yeah.
Because he is more,
health
you know,
wise.
he looks at it like family.
Yeah.
It may be good. Mothers
And the American company that was acquired for the mirrors, that's also doing well. I'm told.
I think only for 1 year we had trouble.
Yeah,
Then,
and it changed because it was made into electronics.
And actually, respected, sir, as far as
Manual,
telephone.
mirror, two cameras and other things.
future cars will not have mirrors.
Yeah.
Acha.
So
they only have cameras and.
पेपर आईडी खत्म हो गई ना?
मेरे साथ तो जरा मेरा
ठीक.
ठीक है सर।
We are about to begin with the session. Kindly be seated. Kindly be seated, please.
I request everyone to take their places as we are about to begin with the panel discussion session. Good afternoon, honorable academic experts, respected industry experts, and our respected board of faculties, teaching fraternities, and all attending students joining us today. I'm Mohammad Shayan Afridi.
And I am Soni Setia, student of Department of Mechanical Engineering, MIT School of Engineering and Technology, MIT University, Noida, and your host for today.
On the occasion of 3rd International Conference on Future Learning Aspects of Mechanical Engineering, FLAME-2022, I welcome you to this industry-academia interaction in the form of a panel discussion on unlocking Atmanirbhar Bharat through engineering excellence. The agenda is about bringing the industry-academia gap and knowledge management and how to frame a better understanding of today's scenario in the new normal. It is expected to foster deliberations and identify joint initiatives for our two fraternities. Let's examine the synergistic opportunities in health, infrastructure, climate, agricultural productivity, SME competitiveness, and make a difference.
So, beginning with the session, I cordially invite our HOD Sir, Dr. Basant Singh Sikawar, for opening remark and introduce our respected academia and research experts and industry professionals.
Over to you, sir.
Thank you very much. Very good afternoon, all of you. I know that after the lunchtime, our body is little bit lazy. But you know that we have to be complete all these sessions within a time. So without taking too much time, I am just first introduce all the speakers on desk. I am say that it is a good opportunity for us. We all academicians and industries in a one platform, and they have to be put their thought on topic of unlock Atmanirbhar Bharat through engineering excellence. You know that there are always in India, people think there is a gap in industries academy, but I believe that all the academies and all the institutes, they are want to associate with industries. So definitely this talk or the view of the industries will be helpful for us as an academician. So first I would like to thank Mr. Gautam, consultant Siemens Digital Industry Software. So Mr. Gautam is moderate of whole events. From the industry side, very renowned, very well known, Mr. Sanjeev Agrawal. He is a DGM in Motherson Techno Tool Limited. Our second speaker from industry is Mr. Bio Misra. He is a Senior Vice President in Soft Cell Technologies. Welcome, sir. And Mr. Sunil Sarad. Sunil Sarad is very, I'm say that, well dedicated especially for a mechanical engineering. Sir, am I right or wrong? So he's a head learning and development in Sandhar technology. I listened 2-3 times. I believe that he is one of the best speaker among us. Mr. Sanjay, I think he will join us late. And Himanshu Bajpayee is also join us. Apart from the academic, so academic, I know these people very well because somehow they are my classmates in a PhD, or somehow they are my collaborator in a research, all these things. So with us, very renowned Professor Dr. Ankur Jain. He is a University of Texas, USA. And this morning, he gave a plenary talk on a lithium-ion battery thermal management. And my very close, I'm say that when I was in IT Kanpur, and he was my senior. So Dr. Pradeep Kumar, he's a associate professor in IT Mandi. He's also with us. Sachin Singh Gautam, people say that senior, super senior, so kind of super senior. He's an associate professor in IT Guwahati. And as you know that always there is we say that some bridge. So you know that academicians generally they publish a paper, all these things, and industries they follow the paper. Yes, can we implement this paper? So with us, Miss Priya Vyas, she's an editor in Spring Age Nature. She's also with us, and she also tried to be put up how we have to connect the academia industries. So thank you very much without delay, without taking any time, because we are also short of time. So thanks to all of you. Warm welcome. Now I'm request to Gautam Datta, please hand over the mic. Thank you, sir.
Thank you, Dr. Sikarwar, and welcome once more. The way we thought that we would do this session is I'll take 4-5 minutes to introduce the topic, introduce the questions that we may have, and then perhaps in 2 sets of questions, because we have, as Dr. Sikarwar said, we have 2 clear sets of people, one representing industry, the other representing academia, and I would, for this purpose, I would count Mrs. Vyas counted in the academia, okay? Please do not mind. I'm just requesting you to represent academia because you probably are here right now from the point of view of academic exposure. So we have 2 sets of people, and the topic as introduced by Dr. Sikarwar is unlocking Atmanirbhar Bharat through engineering excellence. We are not going to start with a debate on whether engineering excellence is important for Atmanirbhar Bharat, because I am assuming it is, because that's why the topic is. We are not starting with that, so that's the first rule, that it is connected. While there are various schools of thoughts in government and non-government and politics that services are important and manufacturing is taking a back seat, we are not getting into that. Yes, it is important for unlocking, especially because of the spread of manufacturing organizations in India, the geographic spread, for driving employment and driving excellence and driving fulfillment of the self-reliant dream of India. I think it is connected, so we assume that, number 1. Number 2, I would also like to draw some terms of reference that manufacturing excellence, for today's discussion, let's keep it as a function of expertise for organizations, which includes two pieces, expertise from knowledge and skills for implementing the knowledge. Both are connected somewhere. Second is the culture of organization. We will be discussing about that. When I say culture, we talk about how quickly, how easily we are adopting the processes, how we are sharing our vision, how we are collaborating, making sure everybody is working together and they're sharing the vision, because I believe that these are a few challenges that we have in our organizations in India. And probably last but not the least is the way we go about solving problems or business problems or facing business issues in the external market, organization facing business issues. So with these three boundaries, I have a few things to say while I'm going to introduce the topic. Where are we as a world and where are we as India to discuss self-reliance is we are facing some trends that we call in the world as mega trends. Number one, the first mega trend is more and more people are living in the city. What we call is the urbanization mega trend, which means we have to develop technologies and ways of mass transit, mass health, sewage disposal, waste disposal, okay? Ease of energy availability, or whether it is, not the traditional sources of technology, of energy, but also the ways of doing like wind energy or anything else that we are working on, solar energy, etc. We are also talking about that's the first trend. Second trend is the demography. We are exceedingly becoming a younger nation. That means there are a lot more people who will be seeking employment. We have to skill them, we have to give them jobs, we have to create value addition opportunities for them to be important and be feeling the value in the society. That's number two. Number three, of course, climate change. We cannot throw that in the window because that's whatever we do today, the emissions and the regulations and the compliances are becoming exceedingly important. Third, and last but not the least, socio-economic awareness of doing and being better and living more comfortably is becoming an aspiration across society. So everybody wants to do better. Everybody has an ambition to live their lives, and fairly so, with comfort. And there is an aspirational intent. So all these four are the trends that bring in when we are discussing engineering excellence. In our work, representing both my organization as well as personally in India over the last 3 to 4 years, which includes the interim COVID period when we faced many, many different challenges, we've realized a lot of people have said, where will the money come from when we are looking at changing the way we do work? And this is a question which I would open a bit later to the industry. I believe if you really ask, money or funding or investment is a function of confidence. And I was talking to my colleague on the table just before coming here. If an investor, a CEO, whether he's a technocrat or a financial investor, if he's convinced that I have team members who are willing to take ownership and there is a clarity of vision and there is a project that is well laid out, there will be investment from him. The reason why there is no investment because his questions are not answered. What will be the returns? How much time will it take? How are you going to go through these changes? What kind of technologies are required? What kind of investments would you do progressively? How quickly can I see the returns? We somehow are not ready to go to the depth of it, and devil is always in the detail. And that's the kind of question I would be discussing. On the other front, on the academia, there are questions like, and this is again I am also part of Amity's, I'm studying with Dr. Sikarwar, and we realize that there is a gap, and the gap is such that industry says, I need it fast. Institutions say, I have to take my own time. Okay? Industry says, I want the commercial equivalent of the business solution. There is a lot of time in the rigors that we are used to in academia for which industry is not bothered. Springer may be bothered about it for printing or in the journals, but lots of times the rigors are not required by industry because they say this is proven, this is known, we know it, you don't have to prove it. Tell me how do I apply it to improve my efficiencies, improve my productivity, improve my quality, and therefore improve my returns. So this amalgamation, this convergence of the culture of academia and the demand of industry is probably still need to fill up. So academia needs to think like an industry, and industry has to start thinking like an academia. And that's where probably the handshake has to happen to create the manufacturing excellence, which is a prerequisite for fulfilling the self-reliance stream. So this is essentially the framework. Is it okay if I come and join you there and then ask use the same microphone? Yeah. So with this backdrop of the topic and the topic details, which is essentially technology, people skills, and business thinking, business mindset, I would like to start my first question, which I'll go and ask, but I'll ask the question and give this, time to first the industry people. The question is, how do they see their ability today? What kind of dependence and challenges, the barriers and facilities that they see for becoming and achieving manufacturing excellence to contribute towards India's self-reliance? So that will be my first question, very generic question. I'll go there and then continue this discussion. Thank you. Yeah, I think it's all right. So maybe my first question is to my colleague here on the dais, to Mr. Sunil Sarath. The question is the same. How do you see manufacturing excellence as a target in industrial organizations of today, with the objective that we need to do, in addition to doing business globally, fulfilling supplies for the customers that you may have anywhere in the world, but also bringing in aspects of self-reliance to India? Yeah.
Thank you, Gautamji, for this question. And then regarding self-reliance in manufacturing excellence, manufacturing has a very long history when it comes to India. So, currently, we see that a lot of, in GDP, a lot of share of service sector is there. But if you will see long back, so it was more of a manufacturing setup. And that is why you will see people with the very strong background, they're working in manufacturing from past so many years. But yes, when it comes to manufacturing excellence, then he rightly said that it has to come in a way like we have to be self-reliant, where I have seen a lot of OEMs who say that I will see you as a manufacturing excellence company when there will be no quality assurance department within the organization. That means that every person who is producing a product should be giving a certification that it is produced first time right and according to the standard of the OEM. So yes, the journey has started, companies are following into that, but there is a long path to go, where we say that the self-reliance part, and it will start from the mindset part. Like he was talking in detail about culture and then people-centric organizations. So processes will be there, but yes, initially we have to somewhere start with the mindset of people, and where every individual has to understand that what is the definition of quality or excellence in that sense. Where does excellence come from? And I will also give you a little perspective from individual basis, like youngsters are there, students are there. So especially in industrial or professional field, if somebody asks another person that how many years of experience you have, so person starts calculating from the day he passes out from engineering or MBA. And then he says that if I have passed out in 2000 and currently it's 2022, that means 22 years of experience I have. But the number of years you have spent in any organization does not equal to your experience. That is the hard reality. But normally we treat it like that. But if it is not like that, why it is not like that? So few people started asking a question that if somebody asks you a question, how many years of experience you have walking? So people start laughing. Walking, there is no experience required. There is something which comes automatically. I need not have to put any effort in walking. Similarly, in experience part, then person need to have a kind of a catalyst. So I read a book from a professional called The Catalyst. He was saying that if you need to have excellence or if you want to grow in life, then you have to have a catalyst in your life, and then it was a detail. So when it comes to self-reliance and self-evaluation, self-awareness, that is the only path which take you to the excellence part, whether it is engineering or your personal life. This is my take.
Okay. Continuing this discussion, I will come back to you. I think we'll quickly go the opening observations. You mentioned mindset. And there is a topic which I would urge all the youngsters here. I think you should go and search for a topic called growth mindset, which is becoming a global conversation today. I think you should learn about how collaboration, sharing, making, right from the vision till the implementation, how sharing and collaboration can help you solve the growth mindset and improve excellence. So that's one thing that came to my mind. The second, I would like to go to Mr. Agarwal and ask this question in a slightly different way. When we are talking about manufacturing excellence and a business challenge comes to you, how do you see today, what kind of challenges you face in driving the details that both technically you require to solve the problem, but more importantly, your management will be seeking the business value of that detail. How do you go about, and what kind of suggestions and guidance you have for the youngsters here as to contribute? Yes.
Thank you. I come from metal machining industry, so cutting tools. And if I look at India, we don't do the basic research work in India. So we have to acquire the technology and then localize it to provide a solution and to do business. So expectation is rather than looking elsewhere, can we start something in India and keep improving it to the global standard? If that can be done, my industry, will be very glad, because then we are not depending on somebody else for technology. It's there in my country. I mean, like for example, if I'm taking technology from elsewhere, it can stop any time because of any reason. But if it is done locally, if it is developed and groomed here, it remains with us, irrespective of the global challenges that arise from time to time. So, request to academia is listen to industry, because we know the market. We understand what market is going to look at, maybe after 5 years, 10 years, 20 years. We can give you that summary, work on it, give back the solution to industry, and then, it works hand in hand. So that is what is our expectation. We don't want to see a paper which is already done elsewhere being presented, but we want what we need, what industry needs to keep itself successful in the market. It can be in India, it can be global. So that is our expectation.
Thank you. That takes me to, let me complete the 3 questions here, and I have some serious questions cropping in my mind to continue the discussion on the academia. Something that came to my mind, the right question to ask you, Mishra, is technology is an enabler. And somewhere we are still in, if you look at India as an economy, we are still in a factor-driven economy. We are probably going towards efficiency-driven economy because the questions of improvement, doing it faster, doing it better are getting asked. But we are still far away from innovation-driven economy. We are not yet ready to take a problem and turn it around its head and say, let's do it totally differently. And therefore achieve 500 times, 600 times, 1,000 times improvement in cost, time, quality imperatives. technology, if technology is an enabler, it is the processes that give us the result. And you have been in this business of absorbing technology, but essentially defining processes which would drive improvements both in terms of efficiency or innovation. What would be your views and how do you enable yourself with technology, keeping in mind that you've got to unlock the locked potential of any organization to drive excellence?
Thank you, Mr. Datta, and good afternoon, everyone. My name is V.K. Mishra. Everybody's awake? Stay awake, guys. So we are looking at a couple of terms here, technology, adoption. So the very basics definition of technology is where the industry or academia has researched and it is patented. And it's a paradigm shift because every level in change of engineering, we can call it a technology. Now it has to be adopted. Once a technology comes to India, in this world, we cannot have, rather India as a country, we didn't develop many technologies on our own. Most of it is imported and then it is, over the years, it has been adopted by the industries. You look at aerospace, look at automotive or other industries per se. So once you adopt a technology, then you do the backward integration. You try to understand the complete, dissect the technology and start improving it, right? And ultimately, whatever ideas or the technologies has to be manufactured is what the discussion point is here. So there is an engineering, R&D, technology. You define it, validate it, optimize it, put it to production. In between, there are a lot of processes because if you don't define the processes, you will not achieve consistency in your product quality. Okay, so processes is the key. And everything is a process because nothing is one-step solution in this world today. So you look at ideation, concepts, detail engineering, validation, everything is a process, including manufacturing, supply chain, likewise. So process is very essential. Not many processes are tied to technology, but every technology has to pass through the process, right? And as we are going today, the world is under tremendous pressure to be more economical, to be more, deliver better products is where the industry, like our colleagues are sitting, to deliver products to the tune of global standards and Indian cost and meeting the customer's expectation, which is the market what we have in India. So I'm sure we are on the right path, but lot of work, lot of support needs to be done from academia and industries in terms of supporting the product, supporting the civilization and the country as a whole. I hope it answered a bit of your questions, but...
all of our answers are actually setting the stage for the questions that are going to go to the academia. And the question that comes to my mind, and I have to give a bit of a background, and the question would be to Dr. Jain to begin with. The term research and development, okay, which is around technology and expertise both, for any organization. But I'm going to split it between the two. Okay. Research is separate from development, and most of our manufacturing, okay, I need to define manufacturing here. Manufacturing doesn't mean only cutting it on the machine. Manufacturing here would mean capturing the customer's requirement, converting it into design, then developing it, then manufacturing it, quality, supplying it, and continuing throughout its life cycle. The entire value chain is manufacturing here. So do not be under any misconception. Manufacturing only means, taking it on the machine. Okay? With that perspective, and I split between research and development, the question is very basic. How much do you think we should be in India to become self-reliant? we should concentrate on the ability to research and the ability to develop different ways of developing and applying the research, because many experts say doing core research is not so important right now, to make sure that we need to apply whatever we have learned across last 50, 60 years and do things better. And that will help us save resources and do more with less. Dr. Jain.
So that's a very good question, and I think I'm very clear about what I think about it. I think research is extremely, extremely, extremely important for India to go up the ladder of hierarchy in the world. You know, if you look 40, 50 years ago, China was the sweatshop of the world, right? They have successfully been able to go up the ladder, and they do now a decent amount of innovation, research, as I would like to call it, and we need to catch up with them and with the rest of the world. What is the role of academia in doing that? I think academia can and needs to play a very, very important role in that to happen. A very simple example that I can think of is the Silicon Valley. Silicon Valley has been the epicenter of innovation in information technology, software, and so on. But why Silicon Valley? One very important reason for why Silicon Valley is the presence of top universities like Stanford University, UC Berkeley, and so on in that area. It is those universities that ended up becoming the breeding grounds for individuals who eventually formed all the great companies of the world, the Googles and the Yahoos and Sun Microsystems and so on and so forth. Sun, in fact, I think stands for Stanford University Network. So I think the role of universities in developing this excellence is clearly very important. We can see examples of that, and I hope that institutions like Amity and others can play that role in taking manufacturing, research in manufacturing forward.
A continued question to Dr. Pradeep Kumar. I think this could be a question to any of the Indian institutes being represented here. How much selling do we do of our capabilities from academia to industry, actually positioning the capabilities which make the industry invest in such research or development projects, whether it is core research or process research? How much selling do you think is happening today, and how much selling we must be doing? Because most of the time it is industry approaching academia with projects and stuff, and they need it. But how many times academia goes and presents its capability like a salesperson, like industry does with each other?
Okay, thank you. It is also a very nice question, and I will give my view on it. Before coming to academia, I also worked with industry. It is basically ANSYS Fluent Software India, and I work in software development department. Okay, so research and development, what we will say, is not separate. It is same thing. Okay, whatever idea you conceptualize, unless you develop it, you cannot do further research. You develop it, you get failure, and you further think on that. This is process keep on going and reach a certain level, then product is developed. Okay, so industry thing, I'm talking about mechanical engineering, which is very, very old engineering, and since the start, I believe since need of human is satisfied through mechanical systems only, okay, and a lot of knowledge is there. And now industry in the mechanical becomes very big, okay. So whatever problem industry has, if I need to give solution for that, I need to reproduce at my place. But my place is something which has different kind of attributes. We have working people is students mostly, okay, who are coming to learn something, but the knowledge in this field has gone very, very high. I believe low-hanging fruits is not available right now in mechanical engineering. So students have to quickly learn it and reach up to top of the thing. So this process is only possible when we have facilities and at our place and reproduce whatever industry is there. But industry is telling on the very big scale, very big thing, and we try to reproduce that on very small scale. Okay, we can, because until unless we reproduce, we cannot provide a solution. And it is very limited in scope, but...
Can you concentrate on the question? How do you position your skills and capabilities to the industry so that industry invests in you? That is my question. It's a it's not an easy question.
It's not easy. That's what I'm trying to say, that it is.
That's why I want you to share it with, because these youngsters tomorrow would be going to industry and they would seek answers, but they need to be aware. So how do you position academic skills which can be monetized? That's the question.
But it is not limited to one field. I will say it is collaborative effect. And we have, whatever industry we are targeting, at least similar expertise could have in with many faculties. And we collaborative it and produce a result, because then we can monetize it. So collaboration is very, very important. Either it is just in our own institute or multiple institute collaborate.
Very good answer. Now that gives me
Earlier I was giving based on I am the person who is going to solve it, and now my question is that I cannot solve it. Yeah.
So
thank you.
Dr. Gautam, the question now is the next stage. We have already established that it will be done by collaboration between academia and industry, and where academia has to present its capabilities. But the real life capability or real life industry challenges is not a mechanical engineering challenge. Neither it is an electronics challenge, nor it is a software challenge. It's a multifunctional challenge. It's anything that we have today. It has mechanical engineering, electronics, software, all put together. They are trying to solve a business problem. And business problem doesn't define, it needs to be solved by mechanical engineering only, which means either fluid dynamics or structural engineering or some kind of mechanism. How do you see academia transforming itself to be multidisciplinary capability building from the industry perspective? While we have to learn mechanical engineering and electronics, but how do we position ourselves as multidisciplinary experts to the industry?
Yeah, so I was listening to some of the, what was said. One was said was, we have to listen to the industry. So my question was, where do we go to listen to the industry? One is that problem. So one is you create some forums. I mean, conferences are one forum where usually we as a researcher meet, but we need to create forums where we as academics position their research from the industry point of view. Industry also comes. So some sort of industry academic collaborations more often. I know in various IITs some efforts are being made, but more of these sustained effort, and within that, like for example, you take software. You have industry academia collaboration for software. You meet once a year, something like this, where I can come and tell this is my capability, and you come and tell this is what we are looking in. And the other thing is your lingua franca and ours is very different. The way we understand certain things, you don't understand. The way you speak, I don't know. If we meet more often, I can understand, we can learn from each other, and then it can happen. So the thing is, if you can keep some of the academics in your decision making, where they can go and learn, and this is what you require, and we can come back to academics and tell this is what is there. And we as academics keep some of the industry persons as visiting maybe adjunct faculty, which is there in the US. They can come and teach us, like, this is what industry needs. That, I would say, will create more synergy. Right now, that is missing. And that meeting thing, I mean, we don't have that. I mean, a conference is a different setup, where more is on research, but if you can have something where from the product point of view meet.
So,
yes.
so there is an action point here. There is a need. Yeah, go ahead, Dr. Jain. You wanted to say something. I'll come to you, Manju.
And just to follow up on that, it is actually quite common. It happens all the time for someone to become a professor and spend their entire life at a university without ever stepping into an industry, right? Which is very ironical, almost unfair. I stand up and I teach my students mechanical engineering, whereas I may have never been on the shop floor, right? That is an institutional change that needs to happen. How will that happen? Perhaps universities might want to make it mandatory for somebody to have had some industry experience before starting as a professor. Perhaps there needs to be something like an internship where a professor takes a break for 6 months and goes and spends time in the industry to see how things work.
Probably even vice versa is important.
Absolutely,
Probably
both
industry
works.
needs to send their industrial people for academic exposure.
True.
As to what kind of capabilities are around in his geography.
True.
To bring that back and and we continue this discussion. We also have Mr. Himanshu Bajpayee, and this, I am assuming you are commercial organization, right?
Yes, I am founder of 3S Fitness Technologies, which is...
Sitting on the academic side, which is what we are discussing anyway.
So, but I would like to, fill in to the agenda which you raised, that how can we, bridge the gap between academic having an exposure to the industrial problem, and I would like to answer it with a business statement, and that is, one person's problem or failure is the opportunity for other, The good thing is that if we look at the industrial ecosystem currently, there are a lot of startups, there are a lot of young organizations like us, wherein we might have an idea, but our capacity to invest and develop a product in that direction is limited because of, XYZ factors and everything. And that specific window is a very good opportunity for organizations like us and institutes and academicians to collaborate and develop that product, because the cost of development goes down for us. Plus, as business guys, we are able to provide a better mapping in terms of what customer needs. So that can be a perfect hybrid model wherein institutions can come and join hands with the young organizations like us who are desperate for success, who are trying hard to innovate and change the ecosystem. Another thing which I would add to this is and first of all, thank you for laying wonderful framework to this discussion. From manufacturing point of view, if you look at Indian manufacturing ecosystem, with all due respect to all the seniors and all the people who have contributed to the manufacturing ecosystem till now, one thing which we, being a manufacturing startup, are still not able to figure out is a question that why haven't we created entry barriers? Right, you look at any industry right now. So I'm a mechanical engineer from Amity only, but my startup is in food manufacturing. Why? Because we are able, as you said, we are using technology as an enabler, creating it as a entry barrier for the rest of the players in the industry, and producing products or innovating products and even patenting some of them, which organizations in US were not able to do in last 15 years. So we really need to see where the failure is happening with someone else, collaborate with them and build on that platform might answer a lot of queries which we just discussed right now. Right? Our focus as an institute should not always be around the big brands or big banners which will provide you with opportunity, because it is not only about the economic or financial opportunity for the students, but also about their learning exposure and experience, which in current or in modern day times, a startup can, provide an ample of that, because you would be working across the roles, across the industries, the team size would be small, so the exposure would be big. So that's my take on that point, that how can we bridge?
That gives me an opportunity to take a 1-minute break to put a perspective of where we stand now. Where we stand is we believe that we need to have excellence in manufacturing, and we believe that is important for being self-reliant, and we believe industry, academia and startup needs to work together. The perspective that I wanted the youngsters to have is their academia has a structured way of working, because that's what they've developed, and industry has a structured way of executing, but the world is changing very, very fast. So there is this unknown for both of them that they need to breach, okay? Unknown in terms of exercising their ability to research and develop, unknown in terms of commercializing that and monetizing that and be successful in business. And that's where startups come in, because there are a lot of last miles, last mile, either integration or interfaces or products or software products, which probably needs an agility to solve. and that's where startups come in. So all these three are now put in perspective the way, and you can make a choice whether you would like to go to academia, whether you would like to go based on your interest and acumen. Is it academic point of view? Is it implementation or adaptation point of view from processes or industry? Or some startup point of view where last miles can be solved? Where do you see how we should transform ourselves to research work?
That's a very thoughtful question, I would say, Mr. Datta, and thank you so much for shooting that at one at me. I would say that, collaboration is the keyword, which we all agreed just now, and we will always agree. That has to be there between academia as well as industry to understand the needs, also to understand the processes, as well as the implementation part. Now, where do startups, stand among this entire scenario? What I see, this is my personal belief, that they come into picture where they have had immediate academic background, and with the learning and learning by doing what they just learned, they have decided to put it immediately into industry aspect. So they can also form a bridge between the academia as well as the industry, where they have gained the knowledge from the academia and they are ready to impart that to the industry side. So that could form a bridge between the two major points to meet the needs of both sides. So this kind of collaboration, can solve a lot of problems. And if, because I was also willing to, contribute to your previous question, that how, the academicians, put themselves or, can sell themselves in the industry. There I thought that, why not, just like conferences is a good way to have these interactions, at least at some level. Then why don't, academic institutions plan tech fairs, at their institutions? That why do we have to always go to a third place to have these tech fairs arranged and, be there? Tech fair could be one of the opportunities where academia can show and, their talent, their developments, their research that they have done. Probably they would also give a platform where, industry people can have the interactions and can understand that what they are making. So these kind of collaborations can go a long way and can solve some problems, if not all of them.
Thank you. Thank you. I think that gives me an opportunity for our last question set for all of us. And I would start from, but before that, let me set it up. What you said just now. Let's assume that we have, whether we call it tech fairs or whatever we may call it, its purpose is collaborating between industry and startups and academia. And the objective is that we interface, we exchange, we know what the industry is looking for. Academia produces that kind of abilities, and startups employ themselves to solve the problems using the latest knowledge and technology that they have brought. One aspect that comes to my mind as a gap in this is our ability to empathize with the business issues of the opposite person, and then my ability to develop a value messaging around it. I would like to bring that on the table for the youngsters sitting here, and that is probably one of the biggest lack in India, and I'm talking very, very my country need, is the ability to understand the question of the person, the business challenge of the person, and break it down into pieces of how much of it is around what I need to do for research, how much is it that I need to do for implementation, and how much is it that I need to convert that into English to convey my message to the other person, because if I'm not able to convey that message, there is no way he's going to invest. Okay? And this is true for both academics as well as, so that I'll start from one end. That's, be able to. So 1 minute each. How do you see the youngsters sitting here? That is the question. That is the focus audience. How do you see us practicing that on a daily basis so that we understand how to ask questions, how to comprehend the answer, and then develop a value message? Because I think that is not taught anywhere. probably the startups learn it because they need it. Facing the Shark Tank, you develop that, right? But we need to have the Shark Tank attitude everywhere in our lives. So that's the question. And that's the audience.
The colleges, academia is the breeding ground for ideas, and ideas they drive the world. So how does the ideas asking question to the industry about, let's say, industrialization of their ideas, which is processes, and then the industry responding back in terms of the language, what they understand, is not as simple as it seems, because that the students have their world of their own, probably a very limited culture and environment where they are, doing the learning activities. So the only answer what I can think of is more closer association is what the startups are doing today. The startups have very fast speed, whereas the industry has a momentum, right? It has gained over. It's a bit slow in responding to any change, but it does this very robust way. Okay, so startups are the one I think entities what is very recently come out of the colleges and started connecting with the need of the society, right? So that's one, and it's already happening, probably a kind of communication, but it has to happen at multiple levels. Probably the students can start working for the industries on their projects. So each industry, you talk about automotive, everybody's going, EV, technology is getting absorbed by the industries much faster way than ever before. Probably a car would be, commercialized and delivered within 11 to 12 months as on today. Is what to 4 models, pulling out every day. So, I'm sorry. So one answer I can give is the academia and the industry has to come more closer to each other. Probably the industry should have their centers. I see, Tata Technologies having a center here. So that could be one. So how we are able to understand each other language. You grasp what industry is trying to convey, and likewise the students. So probably that's one response what I can give. Now over to Mr. Agrawal.
Thank you, sir. What I believe is very similar, that if academia wants to collaborate, then they have to define an objective with industry. The industry where they want to collaborate based on the strength have to have an agreement that the work will happen together, have to accept the deadlines or timelines of the industry, because industry is not, we work under very tight timelines. If we don't succeed within that timeline, the business is gone to somebody else. So you have to be prepared to accept those timelines. And then one fear or one concern is the contact, from both ways has to have consistency. Like it cannot happen that there is a work going on when student completes his engineering or his research work, and then so if this happens, then probably we don't have confidence that next time should we go with such kind of an association or not. So some success and for industry to have confidence. Thank you.
I'll come to a data point later, very shocking data point I wanted to check. That's why I was looking at my phone. You continue.
So question, which is empathizing with business challenges. So for academia, it's must to empathize with business challenges, especially with industry. Or now the paradigm is, are we sending students with the same kind of curriculum, knowledge, equipping them with the same kind of application? Or are they being challenged with the right kind of a skill? So I was discussing with Mr. Gautam before starting of the session that critical thinking is one area which is required very much. So our students have this skill called inquisitiveness, or are they only grasping things which are there in the book or being given to them in the plate? So if we are true with the critical thinking, if we are inquisitive, then nobody will stop.
Because that's how the innovation mindset comes in.
Absolutely. And I think we in academia need to take a look inwards and look at our systems and processes and see what kinds of improvements, fundamental improvements in education and research need to be made. When I was a student 20 plus years ago, I felt that I went through the entire degree of mechanical engineering without really learning a lot about what engineering truly is. It was all about equations and theory and stuff like that, and not a whole lot of practical stuff about how things work. I wish there was a design class where I would sit and design something from scratch, maybe even build it. These days there are 3D printers, right? And you can build something fairly quickly and so on. So I think those kinds of innovations are very important to bring into the education charter of universities.
Dr. Kumar, the same thing. The question is the same. How do you think we can be more critical towards understanding each other? Because that is the key to solving a problem. If we are unable to understand each other properly, then we will not be able to solve.
Yeah, I see one point that industry keep on developing some center in academic. Okay, so that every center, they keep sending their challenges, and students should be going and solving those challenges. If this kind of thing would happen, and we have facilities and we keep knowing industry much more in, say, it's inclusive way rather than exclusive way, we are sitting just imagining what would be problem and like you said, oversimplifying it and giving the problem. So if center would be there, the more cohesive communication.
Got it. I think that's a suggestion. Okay. Dr. Gautam?
Yeah, I would say that we should meet more often. That is one way to understand. The more we meet, the more we discuss. So some forum where we meet as a industry academia. And the other thing is to understand each other's need. That I'm in academics because I liked academics. And so there is a certain way I like researching. So if that also can be understood, I mean, so.
Thank you.
Yeah.
Before I continue this question with Himanshu, because this data is about startups and unicorns. I'm making a point here, and it is an alarming point while we are sitting here and discussing a topic of manufacturing excellence. There are 105 unicorns currently in India, and only 2 manufacturing unicorns. So that should tell us that how much is the need, if we believe manufacturing excellence is connected with self-reliance, Atmanirbhar Bharat, how much is it underrated?
See, it is
manufacturing unicorns. Go ahead.
It is absolutely underrated, and probably it is because of the way we as a society got exposed to startup culture. Right, if you ask anyone who comes from startups, so if you look at my career trajectory, I've worked with corporates and I was part of startups, and then I founded my own startup. I think one is the way we were exposed to startups. For us, the startups were just, as you said, during one of the points you said, technology is an enabler. So just selling the enabler as startups during the initial days. There was no product to back up the company. There was no IP protecting the rights, and it was just a bubble game which was being built upon. One thing which we really need to understand from seniors who are sitting on the desk as well is building a company or building an ecosystem takes time. There is nothing happening overnight, right? I think because of the way we were exposed to startup ecosystem, we lost that patience, and that is why our focus never went on the product side of things, because all of us or each of us wanted to have that quick success in our bag. Now, what happens if you start focusing on the product side of things as a startup? And, as you said, there are only 2 unicorns related to manufacturing in the country. That means ample of opportunities. That means massive white space. That means it's easier for you to get into the industry, scale it up, and probably innovate slightly later, right? You just need to establish that trust that you are the right stakeholder who want to build this 2.0 version of the manufacturing industry. So rather than that point being a negative for me, it's a positive for me. It clearly highlights the silver lining that the opportunity is right around the corner. It's time for all of us to move in that direction and build something great, which ultimately would add to the subject line of this discussion and becoming Atmanirbhar or self-reliant. Because without product, services can never remain self-reliant.
Thank you. I think with that, I think we are just about, I was asked to finish it by 3:45.
I have just last point. I want to add one more point. Manufacturing doesn't mean that only building the product, physical product. It is also software thing. Okay, we need a theoretical backup to improve the product. So if instead of you are looking only for manufacturing the product, it is not only thing. If you are excel in manufacturing the software, that is also a good addition in the progress of industry.
I would end with is that whatever we manufacture in industry and whatever academia supports, eventually it's a promise. Product is just a representative, the promise. Whether it's a product, software product, or a motorcycle, or a car, or a bottle, or whatever it may be, it's a product promise which is represented and backended by quality, reliability, cost commitment, delivery on time, supply chain robustness, all of that combined to make a promise fulfilled. Okay, promise is represented by a product, and if we can remember that, then the rigor comes in, and the rigor is of the community of engineers rather than only academia or industry. So if we can look at it like that and collaborate, like many people said, I think we would be successful. Thank you very much, sir.
Thank you so much, our esteemed panel, and Mr. Datta for such an informative discussion. I now invite the questions from the audience, as the house is now open for the Q&A session. All right. So now,
so when we're talking about industry and academia collaborating, I'm a master's student, so I'm sort of at the interface of academia and industry. Yeah, so I'm a little at the interface of the academia and industry. I'm a master's student over here, and so I'm sort of at the interface of academia and industry. Now the question for we have established that we need to collaborate, the academia and industry. One of the problems with that is that academics don't have incentives to do industry sort of research. Our performance is judged by H indices, number of publications, journal impact factors. So my point to you all is, when you're talking to each other, the industry needs to build these incentives. You need to talk to universities such that our performance is judged by number of technologies transferred, number of products developed. Maybe you can set up journals which are reviewed by industry experts, and they don't judge it from the academic rigor but industry rigor. So we need to have incentives for researchers to actually collaborate with the industry.
I want you to comment on this. This is a very good question. I mean, firstly, Indian journals. Secondly, Indian journals for Indian industry.
Right.
Coming from academia.
So I would say that, any quality research publication is incomplete without sound research. We cannot rely completely on the industry experience or industry orientation of any given work, which will get published or is getting published in a given journal. But I like your idea, and I do agree with you that the more weightage is towards the academic scores of journals and publication scores. So there, I think, instead of focusing on that, if we can have pure industry journals, we do have, where you can consider publishing your research and you will get the weightage. It's not only about, because if you talk about journals, it's not only of the engineering journals. You do have management journals. So focus on publishing on those journals if that fulfill both of your requirements of getting the academic score as well as doing something for the industry which you want to do because you have identified a certain criteria, right? So that would be a good strike, a good balance between the two requirements and going about it. It could be.
No. The thing is, I have worked a long time in industry. I feel that incentive structures in academia needs to change because it is purely based on publications and publications and publications. So this is something which policy planners have to look into.
Yeah, I think you should try and represent that.
Thank you so much, sir. We also have amongst us a sponsor.
Well, I don't know if I quite agree with you on that. After all, the research that people in academia do, even if it is very theoretical, even if it may not meet the needs of the industry as of today, it still might have an important role to play in the bigger picture of things. A theoretical paper that I publish today might end up creating new technologies 20 years from now, right? Just because it is not fulfilling the needs of industry today does not mean that my research is not helpful or valuable. So I feel that there needs to be some conservatism. I'm not saying we need to keep things exactly the way it is. Not at all. We need to give weightage in academia, promotions, tenure, things like that. We need to give weightage to the activities that a faculty member is doing in collaboration with industry. But I don't think a drastic measure like, completely changing how we are evaluated should be done.
Well, I think that there is a there's a necessity for industry to start scanning relevant, research papers in the industry which becomes useful and monetizing it. Because we also are not doing that enough. We are actually doing it again and again, and there are multiple parallel work, duplicacy going on between industry and academia.
Right, and one very good example that I will cite for that is that Google, the company Google, before it became Google, the 2 or 3 folks who started Google were PhD students at Stanford University. They published a paper, and Stanford patented that idea. And that was the root of the Google's search algorithm or whatever it is called. And even to this date, Google licenses that patent from Stanford University, for which it pays hundreds of millions of dollars a year to the university.
Thank you, sir. Thank you so much for your views. We also have amongst us Mr. Harpal Singh, sir. We also have amongst us Mr. Harpal Singh, sir, Manager Sales from Bagel House, USA. I request him to come to the dais and express his views on the conference in like 5 minutes because we are kind of running short on time. Sir, over to you, sir.
Good afternoon, everybody. So, I'm sorry to take you away from this interesting topic which can go on, and I am also very much keen to learn more of that. So anyhow, I will try to finish my presentation as early as possible. Bigger Love's publishers. I will finish my presentation as soon as possible because I know that we are running late. About Bigger Loves. Bigger Loves was founded by Dr. William Bigger in 1991. So we are not a very old publisher, but a very relevant on mechanical engineering, I would say that. Bigger Digital Portal is a state-of-the-art teaching and research information. As I told you that we have a headquarters in Connecticut, USA, but we have offices in across the USA, Europe, Latin America, Asia, including India. Our focus is on engineering sciences, biomedical sciences. I will leave this just, yeah, Bigger Digital Portal. This is our main platform on the web, and you could see that, okay, after US and China, India is the people from India browse it more. Yeah. As I just told you that we Bigger Digital Portal is the online multimedia platform. We have over 40 journals and 130 plus ebooks on the mechanical engineering subjects, and it covers 35 years of peer-reviewed scientific research. And all our journals are indexed by Web of Science, Scopus, PubMed, CS, Google Scholar, and other such platforms. We do have interactive design tools, 3D models, video and animation in our journals and other e-products. Our core area of focus is biomedical research, engineering research collection. So these are the areas which we cover. As our core area of focus, I just told you, thermal and fluid engineering. So these are some of our key journals, and some of these journals, I will just name a couple of them. General Porous Media and Atomization and Space are a bit of a niche journal which are not published by most of the publishers. Legal, House Journals, Competition Science, you can just have a look at that. Yeah, I will just say a bit on this product, which is have a very much industry lineage because heat exchanger is used a lot in a lot of industries, and we have this multimedia product which we developed in collaboration with Imperial College London. It is attached to a software, so it does a lot of your calculation online, which otherwise takes a lot of time, and you can also see the flows in colors, so it's good for the to teach the students also. Similarly, we have thermometer. It is again a multimedia product, so which has a relevance to industry as well. Yes, this is our another vertical that we do publish the conference proceedings of leading conferences like ICHMT and IHTC. And recently, Indian Society for Heat and Mass Transfer and American Society of Thermal and Fluid Engineering had a collaboration, and they did their first international conference in 2017 in its Pilani, Hyderabad campus. Second was done at Roorkee, IIT Roorkee, and third at IIT Madras. It was a virtual last year because of the COVID pandemic. So we have planned to do this every 2 years. So we do have a e-books platform, as I just told you. We have 130 plus e-books. Yeah, this is just a message to all of you that we do give 3 months of free online access to anybody. We do have a personal online access also, free online access, which we give by our username password. So if any professor or lecturer wants it, we can give it. If you have any questions, just let me know. This is my email ID. Thank you so much.
Thank you very much, sir. I once again thank all our industry experts for their deliberations, and now I call upon our head of institutions, joint head, Dr. M.K. Pandey sir and Dr. Abhay Bansal sir, accompanied by our head of department, Dr. Basant Singh Sekhawat sir, to come to the dais as we now felicitate our panel of esteemed industry experts and academia experts. Please welcome with a huge round of applause as we now present a token of gratitude and memento to our industry experts.
I would like to call Mr. Gautam Datta, consultant, Standard Digital Industry Software.
Thank you so much, sir, for an extreme and really great moderation of this discussion. We thank you for your presence, and we are much grateful for your presence in this discussion for the standard discussion session. Give a huge round of applause as we present a token of memento and show our gratitude for his grand presence in our conference.
Next we have Mr. Sanjeev Agarwal, DGM, Motherson Techno Tools Limited. So I request you to kindly. Can we have a huge round of applause?
Thank you so much, sir, for your deliberations and your words. The talk has been really informative on all parts. We really hope that we incorporate these in the industry.
Next, I would like to call Mr. Vyomkesh Mishra, Senior VP, Soft Cell Technologies.
Give a huge round of applause as we welcome our guest. We thank him for his kind words.
Next, we have Mr. Sunil Sadar, Head Learning and Development, Sadar Technologies.
Give a huge round of applause, everyone, as we present our token of memento and show our gratitude for his presence in this panel discussion session.
Next, we have Mr. Himanshu Bajpai, Founder, S3 Fitness Technologies, Private Limited.
Give a huge round of applause as we provide the token of gratitude for our next guest.
Now I would like to call upon Professor Dr. Ankur Jain, University of Texas, USA. Can we have a huge round of applause?
Give a huge round of applause as we present a token of gratitude to our academia expert, and we thank him for his deliberations in this panel discussion session.
Next we have Dr. Pradeep Kumar, IIT Manipur.
Dr. Pradeep Kumar, give a huge round of applause.
Now I would like to call upon Dr. Sachin Singh Gautam, Associate Professor, IIT Guwahati.
We thank you, sir, and provide you with a memento for your grand presence in this panel discussion session.
Next we have Mrs. Priya Glass, Editor, Springer Nature.
Ms. Priya Das, everyone, please welcome her with a huge round of applause. Thank you, ma'am, for your deliberations in this panel discussion session.
Now I would like to call upon the stage Mr. Harpal Singh, Manager Sales, Beagle House, USA.
Give a huge round of applause as we welcome our next guest. We thank you, sir, for your views on the panel discussion.
Sir, better please. What is the formal
Once again,
vote of
thank you
thanks?
so much, our guest, everyone
Just 1
for
minute
joining
only.
today's session. We hope for more sessions together in future. Really hope industry cooperates these amazing ideas and enhance Indian manufacturing, strengthen it and makes it grow further. Thank you everyone.